Good afternoon, everybody, and welcome to this first ever Global TBO Symposium. I'm very pleased to welcome you on behalf of the European Commission, EASA, EUROCONTROL, the SESAR Deployment Manager, and the SESAR Joint Undertaking. My name is David Batchelor. I'm from the SESAR Joint Undertaking, and I will have the honor of being your Master of Ceremonies for this event this week. I'd like to thank you all for being here. We have, I think, well over 200 people here attending physically. We believe we have around 300 people watching online on the various online channels, including YouTube and LinkedIn. Before proceeding any further, we work in aviation. Safety is our priority and security. I'm going to show you a short video about safety and security in this room. Thank you. So I think you will have seen we have a packed agenda for this week. We're going to be talking about all things TBO. TBO is, of course, about improving the predictability and efficiency of air traffic operations. My goal here this week is to make sure we have a predictable and efficient running of this symposium. And therefore, I'm not going to give a long introduction myself. Without further ado, I will pass the floor to Jacopo Pisanotti, the Director of Network Management at EUROCONTROL, who will say a few welcome remarks. Jacopo.
Thank you very much. Good afternoon, everyone. I'm thrilled. Very welcome on behalf of EUROCONTROL here in the Haren site. A warm thanks, apart from all the organizations which are represented, to all the people who took their time and fly here from very far places, demonstrating that trajectory-based operations is the future where we need to go, and demonstrating the fact that we need really to do it in a much quicker manner. So I really encourage all of you to take best advantages of these 3 days. There's going to be a lot of discussions. And again, I really think we need to focus on what's coming ahead. So let me start. I'm an operational guy. I manage the network manager within the 41 member states of Europe. And I just say some simple words. First of all, people want to fly. It seems simple 3 words, but it is what is going on in the world and essentially even in Europe. In Europe today, we are at the levels of 2019 of the traffic with 20% less airspace. But if you consider the load factors that we have today, we have 10% more passengers flying in Europe than we had in 2019. If before COVID, people could prioritize flying at this level, maybe buying their new iPhone first, now people want to move and people want to fly. And this is not going to go away, luckily, because it's a good thing for our business. And I think this is something we all need to consider, that the level of growth and the resilience that this sector is having is phenomenal. We are seeing big geopolitical instability. We are seeing all these challenges from the green and so on and so forth. We are working on it, and there are a lot of organizations together with us which are working to show all these efforts that we're doing. But still, the resilience is, and people want to fly, and people will continue to want to fly. And this is something very important we need to keep in mind, because I genuinely think that we need to be much more disruptive. Otherwise, our future will not be able to manage what are the expectations of the flying public. We need to be much more disruptive, and we need really to act time-based. I see I have they put this on purpose. I have 2 minutes and 42 because they know I'm Italian, I could speak for hours. But my clear messages to you guys is we are too slow, and we need, EUROCONTROL is really working hard to support accelerations, but all of you need to keep this in mind. The speed of growth of aviation and the need for the aviation infrastructure is not going at the same speed of what we're doing in terms to modernize our aviation infrastructure. In EUROCONTROL, we're having a lot of work inside the house. We have our flagship technological program to move to a more open digital platform, which is called INM, which I invite all of you to look at. But also we're pushing forward in Europe with the support of all the organization, 3 major priorities that we believe are important, essentially to support the early achievement of trajectory-based operations, which is really to become more modern, like any other industry, to work really to create open digital infrastructure, to move out of our national closed systems, to really push on air-ground integration, and again, to work in a seamless airspace modeling as we're trying to do in Europe. With these priorities, which are already embedded in the overall work, I think we will be able to really dramatically accelerate and be more disruptive in the implementation of essentially the most important thing, which is the thing we are going to be discussing in these 3 days. And I know on the last day, you will also be discussing about the roadmap, is how you can not only implement the best strategy for trajectory-based operations, but how also this can fit with a more advanced timing strategy, because this is absolutely essential as a prodrome for all the steps that we need to do. Again, I hope you guys will appreciate I'm finishing with 50 seconds in advance, but I really wish all of you guys a great 3 days of work. I'm sure that the knowledge which is in this room and the people connected will allow really to make this leap jump towards more modern infrastructure that the flying passengers deserve all over the world. Thank you very much.
Thank you very much, Jacopo. And it's my great pleasure now to introduce Philip Cornelis, who is the Director for Aviation in DG Move in the European Commission, who will give us the first opening keynote. Philip.
Thank you very much, David. Good afternoon, everyone. And thank you, Jacopo, for those welcoming remarks. Thank you also for hosting this event in the wonderful Europa room here at EUROCONTROL. Thanks also to the colleagues at SESAR for the initiative for this symposium. And of course, thank you all for being here today and tomorrow. I'm pleased and honored to address you at the start of this global symposium, the first one ever, on trajectory-based operations. And I'm probably the only one who uses the full term. Henceforth, it shall be known as TBO. And of course, I will not go into technical aspects. That's not my domain. And there will be many qualified experts here explaining to you the ins and outs of TBO. What I would like to highlight is one particular aspect of this issue and why it's important also politically. The main reason why we are gathered here today is that it's a global concept. It's an operational concept, but it's global. It implies a fully collaborative environment where each flight trajectory is shared, maintained, and used by all concerned actors during all phases of flight, for the benefit of all actors concerned, and ultimately for the benefit of the environment and the climate. So even for non-ATM experts like myself, this does sound like a fantastic concept in these troubled times. Global collaborative sharing. And we need those kinds of projects where we build something together that will make us all better off. Now, the aviation industry has seen quite a few trendy technologies emerging with the promise to revolutionize flying, and more specifically revolutionize ATM, but many have failed to unleash their full potential. Individual solutions can provide some incremental relief to the challenges that we face, but TBO is different. It provides the framework for the continuous optimization of the trajectories of individual aircraft all along their trajectory, from planning to execution, even within congested airspace and, of course, across borders. This is the response to the future global operational challenges of capacity and environmental performance, but which, in fact, we are already facing today in many regions of the world, those challenges, not least here in Europe. From a European perspective, the airspace will remain congested for the foreseeable future because, as Jacopo was saying, people want to fly. and we have a small airspace. The challenge deriving from the current context is to find the means to meet the growing demand for air travel in the most environmentally friendly and cost-efficient manner. And this happens in an airspace that is increasingly blocked for civil aviation by military activity, in the case of Europe due to hostilities on our eastern flank. Returning to civil aviation in post-COVID times, the recent years have demonstrated that the limitations that the air transport sector is suffering, it's not the demand from the passengers, what we thought before, but it's the availability of aircraft, of pilots, of airport slots, and of space on the congested routes in the sky. So we have to work on all those elements. It is peculiar that on the one hand, we have an increase in demand, but on the other hand, aviation is still not very popular, at least here in Europe, among political leaders who are setting our agenda because of its environmental impact. We do not believe that the solution is to stop flying and disappoint all those citizens who want to fly, but certainly we need to fly better. And globally, the aviation sector is engaged in finding solutions to reduce the environmental impact of air transport. That engages all the components of the aviation ecosystem. Manufacturers are developing a new generation of aircraft, highly efficient, new generation of clean energy technologies. Europe, the US, and other regions in the world have committed to roll out sustainable aviation fuels, so-called SAFs. And in addition, we know that aircraft flying optimal trajectories in all conditions, in all parts of the airspace, can cut around 10% of aviation emissions in our European continent. That's what we aim to achieve through a better performing, globally interoperable ATM system. And that brings me back to TBO, global collaborative sharing. Seamless airspace organization, full air-ground integration, and a transition to open digital and cyber-secure infrastructure are the underlying enablers for TBO. They enable TBO, but doesn't mean that they are easy to achieve. But they are needed to provide the benefits that otherwise would not be available. So it's not so much a matter of agreeing where to go. TBO is defined, and I think we all agree on it, judging by how many of you are here today. I think we do agree, but the question is, how do we get there? This question is clearly addressed in all regions of the world, and we will hear from representatives of various regions how they are addressing the move towards TBO. But we need also to address this question globally between the different regions. The how is the real challenge, because the ATM sector comprises a multitude of stakeholders and technological and operational complexities. That makes it very difficult to roll out any new concepts, to synchronize any ATM development and deployment activities. In Europe, we tried to overcome this challenge through the Single European Sky framework, and in particular through its technological pillar, the SESAR project. And we have gone a long way from a purely R&D project to a full ATM innovation cycle that gathers a wide range of stakeholders to define and develop concepts and priorities, and then to bring them into practical operations. This cycle and its underlying mechanisms continuously evolve to adapt to the evolution of the sector and to policy priorities, not least capacity and environmental impact today. In fact, in parallel to the symposium, the SESAR 3 joint undertaking is coordinating the update of the European ATM Master Plan, that is Europe's roadmap for achieving a digital European sky. And the Master Plan will integrate the TBO concept, both in terms of further development priorities and objectives for practical deployment. The ATM innovation cycle needs to commit all the relevant stakeholders according to their roles and responsibilities, and it should make them also accountable to implement their commitments. And I believe similar reflections will need to take place across the different regions to ensure that TBO becomes a truly global platform with the widespread benefits that we believe can be had. Therefore, I'm very happy that the next keynote is delivered by Pascal Luciani, who is representing ICAO and who will help us to bring that global perspective and realize things at a global level. We are certainly committed from the European side to contribute to that. But besides geography, the TBO concept will mainly affect and benefit airspace users. And I'm also very happy that the symposium will have a dedicated panel on military aspects. The military and airspace user with very specific requirements and integrating military needs into the TBO concept is one of the key challenges for the potential airspace transformation that TBO could provide. So thank you also to the military for joining us in this conversation. To conclude, ladies and gentlemen, TBO clearly holds a lot of promise. Shifting to a proper system of trajectory-based operations could revolutionize the ATM sector, just like the arrival of GNSS or digital communication has revolutionized navigation and other modes of transport. I hope that the symposium will succeed in setting the tone for a joint vision for the development and deployment of TBO solutions, a vision that is global, that is collaborative, and that is about sharing. As we prepare to meet also in Montreal for ANC 40 in a couple of months, let's take full advantage of this international gathering to share experiences, to find synergies, to help us find common solutions to those shared challenges facing the ATM sector. Thank you very much for your attention.
Thank you very much, Philip. And as you mentioned, we have the honor also of having with us Pascal Luciani, the Deputy Director of the Air Navigation Bureau in ICAO. Pascal, please give us your keynote speech. Thank you.
Thank you very much. And ladies and gentlemen, it's a great honor to be here and to deliver the greetings and a few words on behalf of the Secretary General of ICAO for this very important event, which is a first of its kind. I would like, first of all, to express my gratitude and the gratitude of ICAO to the 5 organizers, SESAR GU, SESAR Deployment, EUROCONTROL, DG Move, and EASA, in organizing this event. You have been, all 5 of you, leaders in the definition of the concept, in the validation with the stakeholders. You have been strong actors in pushing forward the implementation, and we know we can count on you when it comes the time to finally put this and give life to this concept, which has existed for some time and which is very much needed by our aviation organizations. I would also like to recognize the number and the quality of the participants here. I've had the opportunity in previous lives to sometimes be in that room, and it's not that often that you get a full room and there are 300 people in addition. So that's also great news for the future. Another very positive signal I see is that a lot of what I will say will be repeating what my 2 predecessors said, and a lot of the keywords will already have appeared in the flashing signals that were in the very opening of the video for the opening of the symposium. That's a good thing. It means that we're on the same track and we have the same ambition. Indeed, we're at a crossroads, and we're in a context where aviation is growing and has environmental constraints. Philip mentioned the popularity of aviation. Aviation is popular. I can tell you the vast majority of ICAO members want more aviation. They have appetite for the freedom, for the wealth, for the capacity, for the cultural enrichments that aviation brings. And aviation will grow. And we're here to help this aviation grow. There is also a strong feeling that we have to address the environmental challenges. We have to address it for the perception, we have to address it for the reality of climate and global warming, and we have to address it for the future generations. Under these 2 constraints, we are working on solutions, and the TBO, the trajectory-based operation, is one of the key drivers. It's a triple win. Win for the aviation actors, win for the passengers, and for all those who benefit from the service, and a win from the environment. Therefore, we are all conscious that we have to bring this concept forward. Let me briefly introduce the concept for those of you who may not familiar with it. There are probably not a lot of you among this room. TBO is based on the dream of the trajectory actually followed by each aircraft to be as close as possible to the ideal trajectory, the fastest one, the most straight one, the one which avoids all the difficulties and which delivers as many benefits as possible. This is a concept which is very beautiful in its simplicity and extraordinarily complex in its delivery, because this global concept requires global awareness and global acting in favor of it. TBO relies on the trajectory being taken as a whole from the starting point to the landing point, and globally in its 4 dimensions. In order to be able to interact those 4 dimensions of all the trajectories of the airplane in a global area, which could be in the end as wide as the entire world, extraordinary capacities have to be developed. The information has to be shared, managed, and negotiated over time with the avoidance of conflict as best as we can, with the limitation of the number of instances where there will even be a conflict, and with a demand and capacity anticipation as early, as efficient as possible. This seamless sky that we're dreaming about is only possible if all the actors contribute. How are we going to implement this? We will require all the tools which are needed, including the tools that are offered by the GAMP, the Global Air Navigation Plan, which ICAO is developing. What is ICAO doing to harmonize and develop TBO? Some of the building blocks of TBO are already being implemented right now, notably FFICE, which is going to be implemented soon, and SWIM. SWIM and FFICE are both essential because we need the bandwidth, the instantaneousness, and the quality and trust of information. You can only manage the trajectories over a large area if you have all of this. So these are the provisions which are currently being developed. The next stages are just as important. ATFM will be a key. This will be, there will be a package in ATS for ATFM. And the further we can get, the larger mandate we can get for global ATFM, and maybe a mandate for all states, either individually or regionally, to enact ATFM, and the better we can be in delivering TBO. We will also need implementation. Implementation is one of the key missions of ICAO, and of course the new provisions we will be developing are going to require a lot of implementation efforts, a lot of support, a lot of solidarity for those member states who have the most advanced aviation, so that this can be implemented and harmonized across the world, because we're all conscious that we will only deliver TBO if it's delivered worldwide. One important element in this implementation is that we should not forget the existing provisions, and some provisions which have been existing for years and even decades. It's going to be very difficult to build TBO if we haven't assured everywhere across the planet that the basic provisions of ATM are implemented, and that will be an effort in the future. The challenges ahead of us are many, and this global event will surely help us to define a way, a roadmap to overcome them. There is, of course, the transition itself, which will, as the draft TBO concept says, be more of an evolution than a revolution, and evolutions require continued effort over time and continue us to be consistent in pursuing them. There will be the orchestration of a seamless global air navigation system with new ATM concepts, which will profoundly affect our ability to achieve enhanced efficiency, safety, and capacity. We will also try to work collaboratively, because we have the obligation to support each other. And in that endeavor, TBO cannot be built and cannot be conceived as a one nation initiative. It has to come across the borders. And this is not to implement this also at the worldwide level. In that light, I would like to reiterate the formidable opportunities that are available and how this symposium will allow us to see them more clearly and to energize ourselves to find the courage to harmonize our system, to develop them, and to put further effort in this. The emphasis needs to be put on the need to continue enhancing global cooperation mechanisms to identify ways of implementing solutions that will propel us on a much more direct course for global air transport, ensuring we meet the LTAG while simultaneously overseeing the safe and sustainable growth in system capacity. That's a big program. I wish you a very successful symposium, and ICAO will be watching. We'll be hoping that this first of its kind event will be followed by many others in all the regions of the world, and that we will soon have the pleasure in the Council of ICAO and in the ANC to be presenting the new provisions that bring forward this dream of aviation. Thank you very much.
Thank you very much, Pascal. So this has set the scene, and now we'll get into it. So we thought to start the symposium, it would be good to have a session which talks about why TBO is important. Try and whet your appetite for TBO so that you have this great enthusiasm to go on for the rest of the symposium. So we have a session on operational benefits of TBO. The purpose here is to give some presentations from different perspectives and then to have a discussion with some key stakeholders, both from industry and from around the world, to get different perspectives on the importance of TBO. So we're going to start with a number of presentations. We have Giancarlo Buono, who is the Director of Safety and Flight Operations for Europe for IATA. Razvan Bucarayo, who is Head of Airspace and Capacity Division at Eurocontrol. Hugues de Becco, the Head of the ATM Program at Airbus. And finally, and certainly not least, I'm very honored that we have Mr. Shoji Yoshida, the Director General of Japan Air Navigation Service, or JANS, coming from Tokyo to join us today. So without further ado, I will give the floor to Giancarlo.
Thank you. Thank you very much, David, and good afternoon, everybody. I'm really happy to be here today. Thank you for inviting me to open the session. I'm so happy that today I will not be talking about cost and delays, by the way, and which is my usual subject. And I think there's not much to disagree today on this session. I think we all agree on the benefits that TBO, trajectory-based operation, can bring us. And I would like to start by highlighting and trying to answer the question, why TBO? Well, first of all, I think we can all agree that the ATM system needs modernization. We need to do things differently to cope with current and future challenges. We need TBO to meet the airlines' firm and solid commitment to decarbonize, to meet the net zero goals, and to reduce aviation footprint on global warming and climate change. We need also TBO to solve our well-known airspace and the European network underperformance and address the demand and capacity imbalances that we do have in our systems. We need TBO to enhance predictability through optimized flight planning and tactical in-flight management of the trajectory, where a flown flight path is as close as possible, if not identical, to the user-preferred trajectory. We need TBO to efficiently support the reduction of potential mid-air conflicts by optimizing ATC monitoring tools, and I'll get back to the safety aspect later on. As we heard from Mr. Luciani today, TBO is at the heart of the ICAO's global ATM operational concept. It is fundamental to realize the ICAO global ATM operational concept, and TBO is at the core heart of the GAMP. It is accordingly the subject of several large-scale national and regional development and implementation programs. And in order for TBO to succeed, and to deliver its anticipated benefits, it is of paramount importance that all the processes and procedures that are part of TBO effectively interact, and that TBO is developed and deployed in a globally harmonized and interoperable manner. From IATA point of view, we definitely support TBO. Online, on our website, we have a document which is called the EURETS. It's a formal document where IATA, on behalf of its members, define its position on ATM operational services. Each ATM operational services is classified in one of three groups: support, neutral, do not support. I think you're not surprised to hear that TBO is absolutely supported. So what are the operational benefits that we as airlines see in the implementation of TBO? Let me start by the performance improvement that could benefit the airlines, not only at network level, but also at the single flight level, by enhancing flight planning and its in-flight trajectory based on the specific performance profile of each airframe. Each flight with its own flight performance characteristic, real speeds profile, accurate climb and descent rate, etc. It will also improve flight efficiency to improve our environmental footprint towards our targets of net zero in 2050. Other major performance benefits as predictability and punctuality, and maybe even a better tactical management, could also lead to more capacity gains in airspace, which is already very constrained, without forgetting about the most important key performance area that I mentioned before, which is clearly safety. And we do believe that safety could be benefiting from better predictability and by having ATC flight progress monitoring and other implementation outcomes of TBO. Another benefit that we see is more control on the strategic, pre-tactical, and tactical management of the operation, thanks to the capability of in-flight replanning and prioritization by the operator in accordance with their own business model of each airline. An efficiently negotiated 4D trajectory, providing a reduction in direct operating cost. That's another benefit. In terms of flight cost efficiency, minimizing the gap between schedule and actual operations could provide indirect cost reduction from irregular operations, such as, for example, misconnections, passenger hotels, crew overtime, and overall cancellation that we need to face every day. Delivering more efficient use of ground and airborne operational assets, it's another benefit in terms of better gate assignment, improved overall aircraft utilization, as an example. TBO is clearly a long-term solution, but we need to understand that there are some low-hanging fruits that are already available today, now. And we should not expect that the current ATM suboptimal performance in Europe today will be solved just by TBO. And TBO, anyway, has a different timing. It's a long-term view of the Global Air Navigation Plan and therefore the European ATM Master Plan. However, there are TBO low-hanging fruits, as I said, that we can pick up today. NSPs can rely on modern onboard capabilities that are already installed on our aircraft, as the ADS-C EPP, mandated in Europe by the CP1, that can be already used to build ATC TBO applications. I'm sure that our colleagues of MUAC, together with our friends from Lufthansa tomorrow in session 6, will be able to show our initial trajectory sharing application can actually enhance ATC safety monitoring or provide better, adjust, top of climbs and top of descents, and with that, environmental and flight efficiency benefit. We encourage NSPs in Europe to progress on the deployment of the required ground functionalities mandated by the CP1, to accompany the financial effort invested and to be invested by the airlines. A synchronized approach in the deployment of the AF6 is key to success. For that purpose, the work, support, and collaboration of the SDM, the network manager, EASA, and all the other institutions will be crucial for this endeavor. IATA really appreciates the fact that we are involved in the different collaborative decision-making mechanism, and we're happy to bring our technical support in representation of the interest of our more than 300 members, about 100 of which are based here in Europe. TBO shouldn't be seen in isolation. It's a part of a whole. As expressed by ICAO in its global TBO concept, trajectory-based operations are the glue between these global ATM operational concept components by coordinating the trajectory between different actors and ensuring consistency between the trajectory and constraints that originate this trajectory. TBO supports a performance-based ATM system. For example, the use of trajectory constraints should be minimized to the extent possible and to the tolerance level commensurate with the performance needs that I previously mentioned. To achieve this, TBO requires air-ground synchronized deployment across concept components, leading to a stable, consistent, and robust trajectory solution. Its implementation will never accomplish its objectives and will not deliver the previous expected benefits if the needed organizational arrangements are not complied at NSP and airport level in terms of increased, flexible, and robust ATC capacity, demand balancing, agile and mobile ATCO staffing, resilience against severe weather, which I just saw an example shown me by Razvan this week. In terms of ground enablers, TBO will not be a reality without the modernization and evolution of other parts of the ATM systems. SWIM, as we heard, system-wide information management to enable the flight information sharing platform and mechanism for a flight and flown information in a collaborative environment, FFIs. Increase and modernize connectivity, best-in-class data link and bandwidth is key to enable the required air-to-ground communications performance. Evolution of network capacity and demand balancing mechanism, and NSP flight data processing system to support the negotiation and more efficient handling in the trajectory information that they will receive from the operator or the aircraft. On the air-to-ground side, the ability for all systems to make use of the information made available. This means adapted operational flight planning system, computerized flight planning services to use the new FFI's capabilities to reduce dispatcher and pilots' workloads in the trajectory negotiation process, as well as to have available solution to integrate the FMS computer trajectories with the ground system. Let me finish by highlighting that the private connection that airlines are setting up to interconnect their airline operations center with the aircraft integrated electronic flight bag IP connected with the NSPs for safety-related information exchange could actually also be a subject that deserved more research. Thank you for your attention. Should you want to continue this discussion with IATA or with me personally, these are my contact details. Thank you.
Thank you very much, Giancarlo, and that was a perfect on-time arrival. Razvan, the floor is yours.
Good afternoon, distinguished guests, distinguished colleagues from, once again, from the EUROCONTROL Network Management. It is my pleasure and honor to introduce to you from the perspective of EUROCONTROL Network Manager, why TBO, what are the operational benefits of the TBO? And let's just start with that, the challenge. Just before the COVID crisis, we have reached in the network manager area a peak of traffic of 37,500 flights. Right now, we are at a recovery close to 99%. And for sure, as we progress in the summer season, we will get at similar traffic levels like during the summer 2019. And this is despite the fact that we still have a major crisis, and not only one crisis surrounding the European airspace, but we are getting close to the levels of 2019 traffic. And it is not unimaginable to believe that in 10 years from now, the busy day in Europe will have to handle about 50,000 flights. If we would continue to see the pace of traffic growth as we are seeing it today, it is not inconceivable to get to those levels of demand. And of course, we will have many, many other actors that will need to be integrated in the overall aviation network. So this is the first challenge. What are we going to do together to integrate those elements? It has not been necessarily aligned, but two speakers before were discussing about three important priorities in Europe: the open digital architecture that allows us to harmonize at a regional level, but why not also at global level, system support, technology support, the enablers that we need to deliver the operational performance improvements. We need air-ground integration. We need it desperately. We need to give to air traffic control the tools, the necessary tools, to start reducing the ATC workload. Without an air-ground integration, that will not be possible. And of course, all this needs to be done in the context of the seamless airspace organization. Dear colleagues, here we are making quite a good progress in Europe. FFIs is implemented. FFIs Release 1 is implemented in the network management systems. A large number of airlines are already starting testing with us, FFIs, flight plans, and a large number of ANSPs are modernizing their systems in order to be able to consume the FFIs flight plans. And this is good news. But what we need more, of course, in the context of the open digital infrastructure, is to put together the 40+ systems that we have in Europe with different architectures, with different ways of working, to put them together, to make them flexible, to accelerate this modernization process. And we need at the same time this air-ground integration. I will show you later on a couple of figures in order to make sure that we offer to air traffic control the necessary tools to decrease their workload and as a consequence to increase the airspace throughput, to increase the airspace capacity. And last but not least, we need a seamless airspace organization where, again, in Europe, we have a very good progress. We have implemented to a very, very large extent cross-border free route airspace in major parts of the European airspace. We have a flexible use of airspace concept. We are very much advanced in implementing PBN. And if I start from several years ago, we were the first busy region in the world implementing RVSM, implementing basic RNAV, etc., etc. But we need this seamless airspace organization to eliminate false issues in the network, false issues that are actually creating additional workload for the air traffic controllers. We have a very solid strategic context in which we work as network manager. We have a very recently adopted network strategy plan at the end of the year that gives us the outlook of what needs to happen in the European network until the end of this decade, but also an outlook for the next 10 to 15 years. On the basis of that, we have developed a network operations concept that brings us towards 2029 and beyond. And in support of the TBO, we have developed, together with the operational stakeholders, a network 4D trajectory concept of operations that leads the network part of the TBO concept, leads the conceptual implementation of the TBO concept at a regional level, at the network level. And you will see a lot in the presentations over these 3 days about that. Which are the TBO benefits? First of all, in Europe, we are in an extremely complex environment, like in many other parts of the world. A very dense traffic, a very complex airspace organization, a large number of big airports located in close vicinity, a lot of military activity, and we are starting with the integration of the new entrants. So we need to find the means of providing for planning and operational purposes better ways of the information related to operational and situational awareness. Then The network needs to be very dynamic. There are very much changing conditions at all times. Sometimes we had to scale up very quickly. Sometimes, unfortunately, we've been through that. We have to scale down very quickly also, but to remain fully operational. We need a lot of flexibility during the day, during the seasons, in the planning and in the operations phase. And we need a lot of resilience of the network operations to be able to manage the unforeseeable. Then we need more predictability, and this is what TBO is bringing us, and more accurate demand capacity balancing, both in the tactical operations, but also in the planning phase. And we are talking about meeting the challenges of the demand waves. This is very important. When we are talking about 50,000 flights per day, probably in 10, 15 years from now, nobody would like to fly during the night. We will still have the commercial interesting hours. We will still have the very peak periods of the day. And this is what TBO will help us to do. And this is where more capacity will be delivered and delay will be saved. And of course, the integration of the new entrants, we need to reflect also how TBO will help the integration of those new entrants. All in all, this will give us reduced ATC workload, increased capacity, and I left this at the end, but it is very important, the environmental benefits, because I'm sorry to say, and we repeat it constantly, if we don't have sufficient capacity, we will not have the necessary environmental benefits. Dear colleagues, we have done a simulation to see how TBO can help. And we have done this in the context of the what is happening right now in Europe, the update of the ATM master plan. And we were looking at elements of TBO, but of course, at elements related to a seamless airspace organization. What you can see here, it's a significant reduction of the standard RT. It is a significant reduction of coordination actions, of conflict search, a little bit less on the flight data management. But all in all, when we are measuring this, we are measuring this in the time of processing 100 flights. And actually, if we manage to deliver all those benefits by the end of 2040, we will be able to reduce this by 50%, to reduce the time of processing 100 flights by 50%. That means in practice, when we revert this into sector capacity, in increasing sector capacities from an average of 45 flights per hour currently in Europe to about 97 flights per hour. In terms of monetary benefits, we are looking at reducing air transport delay by about 700 million euros. Environmental benefits of about 6.5 million tons of CO2 and the equivalent of 1.7 billion euros in terms of fuel burn. Reducing strategic delays with structural savings. When you have the planning phase in it, you have less range of the buffers, of the schedule times, you have a much better use of the aircraft and of the fleets. Less variations between the flight planning and airborne phase, allowing us to do a rolling planning down into operations and improvement of flight efficiency and predictability. Dear colleagues, the benefits of TBO are quite significant, and I would like to close this intervention by saying that we need to shorten the times from R&D into operations. We need to work together and to seek whichever possible opportunity to start implementing. Thank you, Chairman.
Thank you very much, Razvan. So we've heard an airspace user perspective, a network management perspective. So let's now hear from a manufacturer. So I welcome Hugues de Becco to give his presentation. Thank you.
Thank you, David. Thank you to give to Airbus the opportunity to express our view about TBO. By the way, what you will see is a rephrasing of a lot of messages what we are given by Giancarlo and Razvan, but just a different format on phasing different things. So why? The question is why. The first answer to the why is safety. Here we are talking about a safe operation of machines flying quite fast, sharing the same airspace. So the first bullet is safety. The second is punctuality. The passengers, the customer of the most of the airspace users of the airlines have a tendency to expect to be on time. That I share. And the last one is our collective duty, which is really to reduce the environmental footprint of aviation. So it started at the beginning with the noise around airport. It's still a very, very big stake. Noise is a big stake, still always. But CO2 and non-CO2 is now the big factor of complexity. We really need to improve the operations. And David mentioned it, and as well as Philip, we are talking about trying to tackle around of 10% of wasted CO2 for the European airspace. What are we talking about? Something which is extremely complex. The repartition of the flow is totally unequal in Europe and everywhere in the world. There are season and daily peaks. The two bullets have tendency to sum up that in everybody willing to fly at the same place, at the same day, and the same hours. So this is creating a huge problematic of traffic flow and capacity. Third bullet is to say this is not simple. We are talking about cross-border on a high number of stakeholders, not only the airlines and the NSPs, but all the institutions, the airport, all the different institutions and companies which are involved in ATM. So this is back to the speech about collaboration and cooperation. It's extremely complex and it's not only technical, by far. Speed. We are going fast. In 10 seconds, an aircraft in cruise is just doing 1.4 nautical miles. And this is also explaining the complexity about the safety. And disruption. So disruption is a key word in our world. There is disruptions every day, weather, but it could be also military, civil, and not to say about the difficulties that can be encountered in airport. So disruption is a normal way of life for us. Why? It was said we need to allow each flight to fly as close as possible to its optimal trajectory. At the same time, we also need to get the best global optimization of the airspace. It's not to say one airfly in the day can fly the optimal trajectory. It's the entire airspace that needs to be optimal. So for that reason, we need to maximize the use of the airspace. And here is a link with the capacity. All of that is respect to lowering the environmental footprint. So the key elements in the game, if I would say to call it a game, it's a question of individual flight optimization, of traffic optimization, relying on the strategic flight and flow planning, and the tactical execution. And the four pieces are working together, such as to really lower the environmental footprint. All in all, the objective is to remove the unnecessary buffers. So buffers is a little bit shocking word, but when we talk about safety and speed, obviously there are buffers to ensure the safety. So the question is now to tackle the ones which are not absolutely necessary to really try to significantly increase the capacity and to allow each flight to fly as close as possible to its optimal trajectory. Two examples, and I am making a teaser for the session for tomorrow, and I'm just thanking MUAC for the example. So Giancarlo spoke about low-hanging fruit. This is reality. This is not research. This is a reality daily observed in MUAC. MUAC using the capacity of some Airbus aircraft to downlink the famous extended projected profile, as well as having the full B2 data link capacity. So the result, and I will not detail because I'm absolutely not able to replace Victor in describing this with the talent he has, but in small red letter, you can see we are talking about track mile savings and fuel savings. So it's either a question of savings, having a more direct route, or to avoid to ask to an aircraft to descend prematurely, just by having, in fact, two key parameters, one which is accuracy and integrity. So accuracy and integrity is the essence of the mandate about the AF6 and what will go on after the AF6. Voila. So this thing just to close this presentation of something which is the reality on the transition, which is to say before, which was from R&D, we need to accelerate the transition into operation. This is a good example. Yes, we can do it. Merci.
Thank you very much, Hugues. And so finally, the last presentation will be made by Mr. Shoji Yoshida from Japan Air Navigation Service. So we'll have a perspective from a different region of the world. It's been a little bit European so far. So let's broaden our horizons. Mr. Yoshida, the floor is yours.
Good afternoon, everybody. My name is Shoji Yoshida, DG of JCAB, in charge of Japanese Air Navigation Services. It is my honor to be here with you, and I would like to express our sincere gratitude to EUROCONTROL, EU, SESAR, EASA for organizing this splendid symposium. On this opportunity, let me introduce the outline of our initiatives towards TBO. In Japan, we are working towards TBO within the CARAT framework. CARAT is a long-term action plan to renovate air traffic system in Japan. Led by the JCAB and in cooperation with industry, academia, and government, a long-term vision is being formulated to respond to increasing air traffic and user needs, and also to contribute to economic growth and global warming countermeasures. The CARAT measures can be classified into 8 categories. Each category is linked to the ICAO ASBU, but the relationship is not always one-to-one. Each category is interrelated and contains measures which are essential to achieving TBO. So we have set up working groups for each category. Because the measures are related to each other across categories, the working groups are also considering with each other to proceed with their consideration. I'd like to briefly introduce the categories. Surveillance, communication, navigation are technological enablers. Meteorological is also a key factor in improving operational predictability. We aim to quantify the impact of weather on operations, including the development and introduction of technology to convert weather information into airspace capacity. This is an essential measure for trajectory negotiations using FFIs. Demand and capacity balancing and airport operations will be the backbone of operations to support TBO. In the DCB field, we are currently working with neighboring countries to implement cross-border CTO, which we believe will be incorporated as part of TBO in the future. Information management is a necessary enabler for collaborative decision-making among stakeholders. Early next year, we will start to provide the SWIM service. As you know, SWIM is a platform service for information sharing and trajectory negotiations, and this will be a major step forward towards TBO. We aim to achieve TBO by integrating these measures. And finally, I would like to introduce some validation activities we are conducting together with various countries to realize TBO. In June 2023, in collaboration with the aviation authorities of the United States, Singapore, and Thailand, and Boeing Company, we conducted the world's first test flight using an actual aircraft to verify the practical utility of TBO. Through the demonstration, we were able to confirm the usefulness of next-generation technology and the importance of information sharing among stakeholders to collaborate for collaborative decision-making. Also, starting this year, we have welcomed new member countries and launched the APEC TBO Pathfinder project, a new demonstration project in the Asia-Pacific region. We hope we can find the best path towards TBO in the near future. Thank you.
Thank you very much, Mr. Yoshida. So that's the last of the introductory presentations, which we will have in this session. And we're now going to move into a panel discussion. So for this, we have, I'd like to say, a stellar lineup of panelists. So we will have Mr. Yoshida join the panel discussion. We also have Simon Hoggard, the Director General of CANSO, Todd Citron, the Chief Technology Officer of Boeing, Maria Grazia Lapiscopia, the Executive Director of the SESAR Deployment Manager, and in a change to the advertised program, unfortunately, Katrina Hall from the FAA was taken unwell this morning, and I'm very grateful to Steve Bradford, who is the Chief Scientist and Technical Advisor from the Office of Next Gen at the FAA, for stepping in at very short notice. So what I'd like to do is pick up on some of the themes we've already heard about, but in particular to get your perspectives on what you think are the main operational benefits. Why is TBO important from your perspective? And maybe I'd start with Simon from the ANSP community. How do you see TBO?
Good afternoon. First and foremost, thank you to the Commission, EASA, SESAR, both parts of SESAR actually, and EUROCONTROL for organising this event. The answer to that question, I think, has already been answered broadly. I think we've heard everybody say very similar things so far, and I'm at risk of repeating what's been said by the presenters. TBO is something for me globally that gets talked about an awful lot. I'm not sure everybody really understands what that means, I suppose, is the first question. We've heard some really good descriptions actually already. But it is a key transformation that I think is absolutely needed globally, not just regionally, but globally. And I think seeing everybody in this room, and I was looking around the room and spotting all sorts of people from all over the world rather than just Europe, and that's a good sign, a good start. Now, a few years ago, CANSO launched a leaders forum called CATS Global Council. For those, so many of you would have heard about it. For those who haven't, it's a Complete Air Traffic System Global Council. And the purpose of doing it was to get the whole of industry, the aviation industry, together to come up with a joint vision, a vision of what airspace, or an agreement of what airspace could look like, and then drive the implementation of that agreement on that global vision. And there's big chunks in this vision, this 2045 vision, and identifying key transformations that's needed globally. And one of those, you'll be pleased to hear, is TBO. So that, for me, being here, seeing you all in this room, actually demonstrates that all of our visions really align. So it's not that difficult, really. We've heard TBO is essential. We need it for greener skies. We need it for more predictable air travel. We need it to accommodate the growth. And we heard people want to fly, and I think that's right. But it's not just volume; it's also diversity. And I haven't heard much about diversity so far. It's the different types of airspace users that are starting to emerge, and they're not new entrants anymore. They're here, but they're growing, and they're growing in all sorts of different directions, with all sorts of different tentacles. So it's that diversity that I think also TBO will help. And of course, doing all of that safely. Now, Razvan has come up with some numbers, some big numbers, and that's a snapshot. Actually, I think it's far greater than globally than the numbers that Razvan has said. We've already heard that TBO involves sharing. It involves managing information across. Well, within an ANSP, actually, is quite tricky with the multiple systems that they have. You can imagine that across a region of ANSPs, then global across ANSPs. It is multiple systems that we need to share information quickly and efficiently, none of which is very easy. But if we can do that, it does become more efficient. We've heard this, it becomes more efficient, it becomes more sustainable, and aviation, for aviation to become sustainable is in every one of ours interest in this room, and probably a vast majority of the people around the globe, whether we like to admit it or not. It needs to become sustainable. So this is a key part of that. Capacity, obviously, I've already mentioned, and safety. Now, that's really easy to say, and it feels right. When we talk about TBO, that it's going to make it more efficient. It's going to make it better. It does feel right, but it does need validating. It does need proving, and those validations are taking place. And you mentioned, the TBO Pathfinder project. That's pretty good. Now, for those of us that live and work in Europe and have lived and worked in Europe for a long time, getting a lot of countries to agree to do something, actually, surprisingly, although it feels really difficult when you do it, is not that difficult when you're in Europe. There's different projects and mechanisms that enable that to happen through the Commission and so on and so forth. But in areas like APAC, Asia Pacific, to have 8 ANSPs working with CANSO and IATA and others, that's quite extraordinary. All trying to do the same thing for the good reason. So it doesn't feel good, massive, but believe me, that's a massive step, and one that I congratulate those people on. Now, I think if you add all that together, I think globally the world is ready to implement TBO. Some countries will be quicker than others, and that's probably okay. But I suppose as a reminder for me is this event, or events such as these, should serve as a joint commitment. That's at the moment, I think, is what's missing, is having a joint global commitment to do this. Because once we've got that, where there's a will, there's a way, is a very English phrase, but that still remains true. If we're committed, I think we can make it happen.
Thank you, Simon. So you mentioned Asia Pacific. We've actually got 2 representatives from countries who participated in those activities. So, Mr. Yoshida, I know you've given the presentation about what you're doing in Japan. Can you say a bit more about the motivation behind the multi-regional TBO demonstration and what's coming next with the Pathfinder? Are you doing this because you see real benefits, and what impact do you think TBO could have on air traffic from a Japanese perspective?
Thank you so much. The benefits we expect from TBO are efficiency, flexibility, and adaptability. About efficiency, TBO will allow airspace users to fly safely on the optimal trajectory and reduce delays in the air. In addition, improved predictability can lead to optimization of onboard fuel. These effects will make it possible to reduce fuel consumption and CO2 emissions. It also ensures on-time flight operation by making a maximum use of airspace capacity. Next is flexibility. Improved traffic flow prediction and more advanced information sharing will provide airspace users with more options for their operations. Airspace users can make the best decision based on their priorities, such as fuel consumption, punctuality, and comfortability for each flight. Increased predictability and advanced information sharing will give airspace users more flexibility in their fleet management. Finally, about adaptability. Even if an unexpected event occurs that affects aircraft operations or airspace capacity, such as sudden bad weather, the impact on operations can be minimized by sharing latest information and optimal negotiations. We are working together, working towards TBO in line with CARAT's, the long-term vision I explained earlier. To achieve a global harmonized TBO, the CARAT's roadmap is being reviewed with reference to CAMP. And I'd like to add that I explained about the Asia Pacific trial, but finally, the most important is that TBO must be implemented worldwide. Thank you.
Thank you. So I want to turn to the FAA. So I know there's a big risk that we all start repeating the same things, but from a US perspective, do you share the same views? Are there nuances or differences of perspective? You obviously have a much larger airspace than most other countries in the world. You're a single ANSP with that large airspace. Does that mean you have a different perspective on the benefits?
No. No, I mean, if anything, it's because we are so large, we've learned that one size doesn't fit all, because we have thousands of airports, not all who get to participate in TBO, but we have like our 15 to 30 large airports. They can get to participate in a certain type of TBO. Now we're truly trying to see how we can make a trajectory-based inroads into the next 100, that you can't afford to do everything the same way. But they all basically have the same premise, that for years, everything's been based on voice and books or voice and paper. United States, we had the Pony Express, where the riders went along and handed off the mail one after another. Well, that's kind of the way air traffic has always been. A little bit of a Pony Express, hand it off with voice, hand off a notification. We've learned that we can't do that if we want to actually make the airspace better. We really do have to automate those handoffs, that information, and you have to be able to anticipate when you're going to get the stuff. And that's what TBO really brings you, that the anticipation, the knowledge that you're going to get something, not parameter time before somebody shows up in your sector, but you actually can plan for it. And so I say no. We just have more opportunities to try more things because we have a very large country. And yeah, we can do multi-center time-based flow management because we can reach out and touch an aircraft 500, 600, 700 miles from an airport, but we still have to try to work on the small airports. And how do I include them? The ones that feed Chicago. I mean, not every aircraft goes from a large airport to another large airport. So I think it's the same problem everywhere. We do have the advantage of having a single information system, sort of.
Thanks, Steve. And Mario Grazia. So we've heard quite a bit from a European perspective, but you and the SESAR deployment manager are a consortium that includes not just the NSPs, you have the airlines and the airports. We haven't heard much about airports yet. Do you think from your perspective, is there a very strong drive from all of members of the SDM towards TBO, and do they all share the same view about the benefits?
Yeah, for sure. So there is a common sharing of the benefits with regard to trajectory-based operation, mainly because we need to face together the challenges that were mentioned before. So an increase of traffic, a problem in terms of capacity, and the problem on capacity at the risk of congestion and delays, of course. And when there are congestion and delays, there is the big risk to consume more fuel than necessary, and so increase CO2 emission. And we all in the membership is all very attentive to this part of the benefit of trajectory-based operation. So less fuel consumption and less CO2 emissions. What we are doing now is to put in place the building blocks of trajectory-based operation that are in the common project one, that is was mentioned also before, that is a mandate that SDM, which implementation the SDM is coordinating, trying to move all together in Europe. Not an easy task, but there is a big effort to make it happen. So what we have done also to, incentivize the investments, in particular from the airlines perspective, is to put in place a strong CBA to analyze the benefits of these building blocks that are necessary to move towards the full trajectory-based operation, in particular ADAC, EPP. So from the analysis that we have done, the benefits are really going much beyond the expected costs. We are talking of in around 10 years, the positive NPV for Europe will be around 1.8 billion. That is thanks to air navigation services productivity gains we were not mentioning before among the advantages and the benefits of trajectory-based operation, and also, of course, again, the CO2 emission reduction. So if we count for every flight, what we have calculated is that we have a saving of 30 kilo of emissions, that is more or less 10 kilo of fuel per flight. But this is an average calculation. So if we move to more congested areas, the benefits will be even stronger in terms of fuel savings. So when a acceptable number of aircraft will be equipped, I'm talking about 70% of the ECAC area, and more or less 3,000 and 500. So we have calculated just for the ADSP, that is one of the main building blocks of TBO. The yearly benefits will, in terms of emission, will surpass the 350 kilotons per year. So I think we have a lot of numbers, but definitely if we start with the main enablers, we can imagine what else can come on top when the full trajectory-based operation will be implemented. And from all the members, there is a full commitment to move forward in this direction.
Okay, thank you, Maria Grazia. So I'm going to turn to Boeing. You're designing and selling aircraft. I'm hearing everyone agrees that there are these fantastic benefits from TBO. When you're selling your aircraft, how prominently does TBO feature in the discussions?
I think I'll start with there's a lot of shared interests here. And I think that's what we need to leverage to make this all work. We know that humans have an innate need to connect, and the resurgence of air travel after COVID just is another proof point of that. And we need to enable that. TBO is part of that. We have a shared interest in reducing the environmental impact of aviation. And again, TBO can help with that. And considering that most of the planet hasn't set foot on an aircraft, we also have a shared interest in continuing to grow the capacity of our air traffic system so that we can support that. So I think we have a lot of shared interest. And one other shared interest, I think, is this, which is we would all like to see the benefits, all of those things I just listed, sooner rather than later. And that was really the focus of the demonstration that we did with Yoshida-san and folks in the United States, Steve, as well as in Singapore and in Thailand, was to demonstrate some essential concepts. Because at its simplest form, TBO is about gathering a distributed set of information, bringing it to a common point so that you can optimize. So real trajectories, local weather, local congestion. And so, all of that is important to all of our customers that we serve. And But again, we want to make it as simple as possible to get there. So in particular, in the multi-region characteristic-based operations demonstration, we wanted to be able to use an unmodified aircraft and demonstrate how it could participate in TBO, because in the end, the benefits of TBO scale with the number of participants. And so by using an electronic flight bag that you can walk on the aircraft as opposed to modify the aircraft, and the connectivity to the flight management system that exists on most aircraft, ours, Airbus, and others, we were able to leverage that functionality and still demonstrate TBO without modifying the aircraft. Similarly, a lot of the expense and the inertia to get there is being able to get that digital connectivity from the aircraft to the ANSP to do that optimization that I mentioned. But a lot of the airlines already have that digital connectivity with their fleet. And so we can leverage the connection from the aircraft to the airline operations center, the NSP. And it doesn't change our North Star of where we want to get to, but both of those technologies or approaches that exist or can exist today, and they allow us to go much faster in getting benefits from TBO as we step our way towards the North Star, towards that end state. And so we're really focused on, how can we help make TBO happen faster? Because all of those shared interests, we need those sooner rather than later. And when we talk to our customers, they're certainly very interested in how they can gain those benefits more rapidly as well.
Thank you. Yoshida-san, you've mentioned already the demonstrations that will be done in Asia Pacific. In terms of what you're doing to try and make TBO a reality, is there anything else you want to add in terms of the concrete steps that you see need to be taken in Japan to move towards TBO beyond the demonstration activities?
We are under study, as you, all the stakeholders, like all the stakeholders, we are under study of how to realize TBO. So, but we are going to revise our CARAT program to, we made it in 2010. So it passed already to 14 years. So we are going to the other one in collaboration with you. I think again that TBO can be more effective if it is implemented worldwide. And I hope ICAO needs to play a central role in formulating the implementation plan for FFIs and other systems so that all stakeholders can proceed with implementation based on a common understanding. Thank you.
Thank you. So, Simon, you mentioned you think what's missing is a joint global commitment. How do we get this joint global commitment? And is it really as simple as that, or are there other obstacles you see? I'm kind of intrigued a little bit by the fact that at CANSO level, through the CATS process, TBO is clearly seen as a priority. We've heard that we want to accelerate TBO somehow. What needs to happen to make this move forward, in your view?
If it was easy, I think we may have done it already. I suppose is the easy answer. I mean, I can talk a bit about some of the things we are doing, and we are doing stuff. It's not we're not doing anything, I think, around the world. I'm happy to talk about the obstacles and challenges, many of which have been said, but I'll start with perhaps what we're doing. And for me, at the moment, it's probably more about lobbying and advocating and trying to drive things forward. I mean, FFIs, I think, for example, is probably the first one at the top of the list. We need it in. It needs to be implemented. It's got to replace the current flight planning that we have. If you'd asked me a couple of years ago, would I've ever heard myself say that? Probably not. But it's moving on quite quickly. FFIs needs to come in. ICAO, I think, has the intent to discuss this at the ANC later on this year regarding, I think they call it the sunset date for Flight Plan 2012. I completely support that. Absolutely support that. There is a massive first mover disadvantage for many people at the moment by going first into FFIs fully on the basis that they've no idea when Flight Plan 2012 is going to end. The costs of running two relatively complex systems for too long is probably prohibitive. So how can we turn that around to make that a first mover advantage, get some certainty? Again, with FFIs, we've got the phase one, we've got the phase one pre-departure info sorted. Phase two, we need a bit more from those. It's not been released yet, so that should be accelerated, I think, as much as possible. So that's one thing I think we are doing, but we need to do a lot more of. I keep hearing swim. Now, I've obviously been in the industry far too long, because swim has been used for as long as I can remember, many, many years, and yet we're still talking about we must transition to swim. I think we do as an industry do a lot of swimming, for want of a better phrase. But we do need to transfer, whether that's architecture, system-oriented architecture, as it often to get used. I think some ANSPs so we're promoting that, and as an ANSP community, we know we want to do that, but some ANSPs are struggling to implement swim. Part of that's investment with the technology required. Others, it's about waiting for their neighbors to switch, because without their neighbors doing it, it's a waste of time them doing it all on their own. So again, you've got this no first mover advantage, which is a real challenge. I would perhaps look to our ATM suppliers, our suppliers to the industry. Can they please just offer a really simple, easy answer technology that's really quick and easy to implement? Thank you, Marcus. I see you got a thumbs up. So it's really, if that was readily available, then great. What would be stopping us? I'd ask for that. But then you've got other countries like the UAE that I think have worked with EUROCONTROL, and they built a gateway. They built that gateway to make sure that they have swim available between EUROCONTROL and themselves. So it is possible if you've got the time and the investment capability to do it, but that's not all across. I suppose the last thing, and I'm fascinated with what you just said, Todd. I like this briefcase coming on board of an aircraft you can plug in. I think I love a briefcase to go into most ANSPs, I think, to plug in. But I think if we had that, I think it comes back to upgrading again, or the application of data links. There's lots of language that gets used around ADSC and so on, so EPP and so on. I really have no idea what most of that is. But what I do know is it's the ability to send complex messages up and down to people in the air and on the ground, and to use those messages to change things for the good. And we do it all day, sat at our desks. I'm doing it on my phone right now. It should not be that difficult to do that in our air traffic system. So what needs to be updated, we should update and modify those. And again, that's what we're pushing. So there is lots of stuff that we're all doing. So you come back to the global picture. Are we all doing it harmoniously and together? No, because that's a really difficult thing to do. But I do think if we can make that more harmonious and bring more of those things together in things, and I'm not saying it because CANSO is a big part of the CATS Global Council, but it is a body. It does exist. Most people in this room are part of that, including SESAR, JU. And if we can demonstrate and keep driving that implementation through groups like this, through events and groups like this, through groups such as the CATS Global Council, then I'm sure we can get some way towards that global commitment.
Thanks, Simon. So Steve, Simon says it's easy, or should be easy.
I'm not sure I did, but
is it easy in the US? And I've only got like 5 minutes. But
The answer is no. No, I'm just kidding. I think many of us backed ourselves into, with good intentions, backed ourselves into large implementations for decision support tools, which require lots of servers, lots of processors, lots of displays, and then you make great progress the first 7 years, and all of a sudden you're stuck with a large investment that you have to keep sustaining, and that's been one of our problems. I do think that if we actually were to grab hold of some of the more modern technology, and I realize this is a TBO, but I do believe that if we were to go more to cloud-based, get away from this this huge investment in owned infrastructure, we could go faster. I definitely think that it offers a lot of opportunities to places that have not that large invested to go faster. And I think some of our suppliers are beginning to look at that, is how can I provide services quicker, easier, more manageable in a not owned infrastructure. And I think that's important. I think also that we have to be open to, like Todd said, open to new ways of doing communications, because we are still relying on many things on that state-of-the-art stuff we invented in 70s, 60s, 70s, and we keep trying to use it. I mean, our modern datacom is 40 years old, and we have to figure out how to get past some of those things that were implementing things we did with voice, like once again, and figure out how to be more IP based. And I really think that's the most important thing. And FFICE is a good example of, let's get away from what can be shared via voice and get into something that can be more actionable and quicker and faster and carries more information. So for us, it's going to be backing out of a lot of our already investments into more flexible investments.
So Todd, I think I'm hearing, moving to an open architecture, cloud-based is what I think many people, if not everybody, agrees that's where we want to, the direction we want to take. You yourself talked about this kind of thing, but we know to do that you need a transition both not only in the air but also on the ground. I'm going to be a little bit provocative because also I know the ground systems are not represented on this panel. But for you as a manufacturer of aircraft, are you frustrated with your partners who manufacture ground systems?
I guess we look at it differently. Just for me personally, there aren't problems, there's opportunities. And so there's opportunity. And we also look at it as we make a lot of parts of the aviation system. We certainly don't make all, but we certainly, as Boeing, feel responsibility to help optimize the whole, even if they're parts that we don't control. So we have people working the total integrated problem because we think it's in our interest for the public and for our customers that we work that. So no, I wouldn't say we're frustrated. We're really looking for how do we do it. And I think the key is if we're flexible in our thinking and if our objective is to get benefits as soon as possible, what are the pathways to do that? How do we reduce the burden on an airline to participate in TBO? How do we reduce the burden on an ASP to participate in TBO? How do we leverage the economics that drive investments for efficiency that are apart from TBO to actually help implement TBO? And so I think things like the carry-on electronic flight bag, the leveraging of the digital connection that already exists in many cases to the Airline Operations Center, those are just two examples, and we could talk about more of how we can leverage trends that are already happening and use them in a way that accelerate the benefits of TBO. So I wouldn't say we get frustrated. It's more, okay, let's see how we can take advantage and leverage trends and capital investments to help achieve this objective faster, because I think we can go faster.
So, and by the way, I'm on very thin ground here because we have many ground system manufacturers in the membership of my organization. And I'm waiting for brickbats to come towards me. But how is there a room for, or do we need incentives? Do you think we need mandates? Do we need financial incentives, economic incentives? How do you see that?
Good question. I mean, on the one hand, nobody would say no, right? But it's nothing's free. In the end, nothing is really free. I mean, there's always a cost to any different approach. So I think it's a combination of things. What are the trends and pressures that are already pushing the system in a direction? Again, the airlines put in that digital capability for their own economic benefit. It made business sense. So I think we need to look at where are the trends and pressures already existing and what's the gap. And for the gap, that's where one could consider incentives, or another part of this would be how do we get enough of TBO going so we get that flywheel moving that then incentivize more of the community to participate, because you won't be competitive unless you're part of that system. So I think it's not just kind of one answer or the other. I think it's really looking at a more surgical way about how can we leverage existing pressures, whether they're economic and whatnot, and then thinking about that gap.
Yeah, Mario Grazia, Simon spoke about the first mover disadvantage, which I think in Europe is something we've talked about before. How do you see that in relation to the question about incentives?
I think, and also to tackle a bit what you asked before to Todd, we need the support of funding is helpful, but it cannot come alone. So we need a coordination and synchronization of the implementation, and that's where I see the stakeholders, at least from the role of the SDM has to count, that are counting on us to guide a stepwise approach. What is accelerating the implementation, especially on the airline side, is to see the benefits of what they are supposed to invest upon. Of course, what they also want to see that the ground is moving at the same page, because it's where we are having some issues now in Europe, and it's where we are tackling and we are addressing some supporting initiative, in particular on FFIs, where there is a joint work with network manager, but also on IDSC PP, where we are now launching a program to support the next steps of implementation. And this is helping because stakeholders, they need that they can move together, because without a synchronized approach, you lose the advantage, of course. You lose the benefit of the implementation. And this is where we were, the discussion we had in the last years in Europe around the VDL Mode 2 data link was also around this. Yeah, that's it.
Thank you. I'm just going to turn to the presenters, Hugues, Razvan, Giancarlo. Is there anything you've heard that you provokes a reaction or that you want us to supplement from your perspective? You're all thinking. Hugues.
Yes, there was an appetite to make TBO something real worldwide, which I personally share, but making it in Europe, it's already very, very difficult. So adding complexity to a complex problem is not really accelerating the solution of the problem. So this is why we need really to clearly identify with you, Simon, what does it mean to have a real move forward worldwide while speeding up Europe, which is a continental, extremely dense area. And what we are talking about, it's continental dense area, which in terms of operation, again, back to speed and safety, is not the same as larger areas. So the way to make something worldwide is something which is really important to be looked at. Again, we shall not decelerate Europe. We shall think about the worldwide approach for sure. But one is not against the other. We need to make both at the same time, just adding a little bit of complexity.
Razvan?
It was exactly the same, but probably I will tackle it from a different perspective. We absolutely need to work global on the TBO concept, if not for all parts of it, because there might be different understandings of what TBO is, but the TBO has a central element that is the flight intentions of the airlines. I don't even dare to say flight planning. It's flight intentions of the airlines that the TBO will bring in an iterative manner from planning into operations through a negotiation process. And that cannot simply be regional. I don't see how this can be regional. It must be global, because flight planning, and now I'm going to use the word must remain a global element. We cannot ask an airline flying from Asia into Europe to fly to file 5 different flight plans for the very good regional reasons that we all have. And I think that that must be avoided by all means. On the other hand, there are other elements of TBO that help in reducing, and I'm coming to the air traffic controller workload, that can be implemented in regions with more demanding needs and more urgent needs, can be implemented faster. I think we will have the great opportunity during those 3 days, and I'm a little bit the privileged one because I've seen some of the presentations before. We will see different steps, different passes of implementation. Some regions are more advanced, some regions are just seeing it. I think what is important also is to have a common understanding of what is TBO, what we want to achieve from it globally, and what we want to achieve from it locally. At least for us in Europe, if we don't do the air-ground, the true full entire air-ground integration quickly, we will not be able to handle what we need to handle in the next 10 to 15 years.
Giancarlo, thank you, Ruslan.
Maybe just to reiterate what has already been said, but 2 extremely important things for us. The first one is synchronize deployment in the air and in the ground. I mean, if we look at the past, there's a lot of reason for being optimistic. We've been flying around very fancy avionic kits for years without being able to use them. So that's something that clearly needs to be tackled from various aspects. I do understand the perspective of Hugh in terms of not the entire world is ready for certain things. However, as Razvan has said, we are a global business by nature. We fly across regions, and we shouldn't be stopping somewhere to change our equipment on board and then fly again. I'm exaggerating a bit, but that's exactly the reason why ICAO was created, if I'm not mistaken. And we don't certainly want to go back to 1938 when we were flying, from Italy to Brazil, and every stop we had to change procedure and the way we worked because every country was different. So that's why we created ICAO, and I think it's important we continue to cooperate within that framework to ensure that we do have global solutions that are harmonized. Otherwise, we won't succeed. It's like I always make this joke, but free routing airspace over Vatican City. Well, thank you. Yes, that's not really very helpful, right? So we need global solution that can be implemented across regions. Thank you.
Thanks, Giancarlo. I was going to ask about ICAO. So you already mentioned ICAO in your answer there. What is the role of ICAO? And maybe that's a stupid question because we all know what the role of ICAO is, I think. But in this context, what can ICAO be doing? What do we want ICAO to do to help support this globally harmonized steps towards TBO? Steve?
I think that we have to remember that at the very base, you have to have the same common enablers. So FFICE is an enabler. We all need to have the FFICE. Any digital exchange of information that would be used for ATFM, we should have a common standard for that. We don't all have to have the same end tool. I mean, but you have to be able to have all the same core information, and it has to be harmonized, and the exchanges have to be the same so that you can tailor your operations to what you need to do in your region. Like I said, I can manage aircraft 500-600 miles. My time-based flow management tool will be different than somebody who can only do it 100 miles or 200 miles, but the core information has to be the same, and the trajectory the shared has to be common across those things. And so I really think sometimes we spend too much time on the end tools and less time on the real enablers that we need in order to make this thing really work. And ICAO can help lead us to that. The guidance documents and FFICE is important. Even the trajectory-based concept, which says, here's how you should view it, can be really important. And then, of course, the comm standards that flow out of that are important.
Any other views? Maria Garcia?
Oh, I mean, I fully agree with what has been said by Steve. So where the enablers are extremely important, and I think there is already a clear idea what are these enablers, and we need to move forward globally. We need a full and shared among everybody interpretation of what trajectory-based operation is, and that is the role where I see a strong role from ICAO. So is to guide us to have, we all need to have a productive approach and cross-fertilization among regions to really move forward together. And ICAO is the global leader on that. Yeah.
Todd?
Yeah, just to build on what Steve said. I mean, TBO is all about gathering information from distributed sources, bringing it to a point to optimize. And without that common definition about what those information sources are, how they're labeled, basically that standard, I think it's difficult to have a single global concept. So I think ICAO can clearly provide a role of providing that architecture for the information that's necessary for TBO.
So I think we can conclude that we all agree we need to do TBO. TBO should be easy, but maybe it's not easy. We have 2 days ahead of us where we're going to have some very, as Razvan said, some very detailed presentations on different aspects of TBO, not only detailed presentations. What do you think would be a successful outcome of this symposium? I've stunned them.
I'll give you one thought.
Todd?
Just come back to we in our passion for our ideas, but I think we got to keep remembering that there are a number of significant and shared interests, and if we can come back to those and realize if we want to achieve those interests, we have to find a way to collaborate globally. So I think, well, it would be nice to walk out of the 3 days with here's the answer and here's the software release and blah, blah, blah. I suspect that's unlikely, but just, if it's not, great. But if we could walk out with, realizing we do have these shared interests and an agreement that we are going to work together, we are going to collaborate to come up with the standards that enable TBO, that would certainly be very helpful.
Simon?
I suppose as a request in here, as much as what I think would be a success, don't reinvent the wheel. I think we know many of the moving parts for TBO and what's needed, and I'm going to sort of link back to what Steve said and Maria said. ICAO, I always like to blame ICAO. They're easy to blame for not making things happen. It's particularly unfair, actually. Industry needs to help. Industry needs to help ICAO. They can't do it on their own. It's just impossible for ICAO to do it on its own. So we need to work out how industry and ICAO can work together better to accelerate and speed up these standards, which is needed for implementation. So that's probably the first thing. The second is, for this to be a success, is don't get lost. Is not getting lost in all the technical wizardry and brilliant new shiny things. We need to remember, I think, that there are vast areas of the world that still need air traffic flow management. They still need long-range air traffic flow management, which are all both the precursors before you can even get anywhere near TBO, and they don't exist. Again, ICAO, perhaps we can help ICAO with that, with long-range ATFM standards and so on. But there's a whole part of the world that we need to bring with us to make this work. So starting at this end and forgetting about this end will make this symposium unsuccessful. So that's a very negative way of looking at it. So it's about saying there are some stuff that we all know how to do, but some of the world isn't doing. So let's just make sure we include that in any of the solutions that we come up with.
Do you think we have a clear enough roadmap towards TBO? Steve?
My opinion on roadmaps, I think if we laid out the enablers and we had clear definition of when the enablers are coming in and look at their dependencies, I think we'd be okay. I'm less concerned. What usually happens if you if my bosses want a roadmap, they want to know when's the shiny tool showing up and not when the enablers are showing up. And I think, yeah, we really do need to focus on getting the enablers done in a timely fashion. And then the tools will come with them. But otherwise, yeah, everybody wants a roadmap. They're pretty. I've done several for Datacom recently myself, so.
Any other, at the risk of going down a rabbit hole, any other views on roadmaps?
I love a good roadmap. I'm just for Steve's benefit. I think roadmaps have a value as long as they're signed up to and committed to. Having a roadmap is great, but if you're not going to follow it and you're not going to deliver on what's in the roadmap, then they're a waste of time. I suppose again, if you're going to make a roadmap, make it simple. Don't have 1,000 steps when only 5 will do. You know, make it easy and simple. Right at the very beginning, it was said about don't make this complex, keep it simple. That's the only way you're going to make it global. And I think that's what you were trying to express. Keep it simple. So having a simple roadmap has massive benefits, and it has to be deliverable. Yes, you can have extraordinary things in there, but it has to be deliverable and not fantastical.
Thanks, Simon. Todd?
I think an important question is a roadmap of what? And that sounds like a silly question, but if you think about the internet and the internet protocol, we have a very, very distributed system, as we've talked about, a very fragmented set of players. And if we think about having one unified, fully complete architecture, I think we need to ask, is that the fastest path to start seeing the benefits? On the other hand, if I think about the internet and the internet protocol, developing a set of core standards of information flow that enables everybody then to innovate around, it provides the essence of what you need for TBO, and I think it gets us there faster. So I think it's really important to ask a roadmap for what?
Thank you. I mean, it's an interesting discussion because anyone who's looked at the agenda for this symposium may have noticed that in the last session, we're going to have a discussion about the roadmap. So, Hugues first.
Here I contradict what you say because I believe in the importance of having a roadmap. Of course, the first thing is to put in place the enablers, but the enablers are the first step of the roadmap. And then we need to move all together against some steps that are defined within a roadmap. At least here in Europe, it's very important because it's the guidance towards everyone that needs to do investments to make something happen. And of course, everybody have to work together, the stakeholders, the institution, the international organizations, everybody then to make manufacturers, we tend to forget sometimes the manufacturers, but the manufacturers to make it happen timely. That's why I believe in the importance of the roadmap because it's a way to guide a coordinated deployment. Starting from the enablers.
Steve?
Okay, so I'm going to back off a little bit because I do like a good roadmap. My problem is, and I've done them myself, is sometimes the roadmaps will have steps in them, but there's really no connection between the steps. And so then it looks nice in time, but there's no way to get there. So, and I'll take full blame for this because I was one of the people that did it. If you saw the Datacom roadmap in 2018, we were all going to have a B2 at some point, but it didn't really explain how we'd end up at B2 at some point. And so I think that's one of the things that the more recent roadmaps have been doing is they were going, okay, let's be honest. The things have to be done in order to make that happen. So if it's real, if it's commitment, I agree with the commitment. If there's a transition in the roadmap, I'm okay. If it's just a pretty set of squares with labels, which I have done, then it's not okay.
Thanks, Steve. Hugues, you wanted to add something?
Yes, merci, David. Having a roadmap is not the magic solution, but not having a roadmap is probably creating a problem. If we want to go somewhere, we need to go at least roughly where we want to go. So it has to remain simple, yes, high level, not too much in the details, and rather than very well detailed the diversity of what are the different air navigation systems worldwide and what is the diversity of TBO. So we will have to embed the diversity. We will have to rely, as said John Carlo, about, yes, please, if we can avoid to have to change the avionics when we cross the Atlantic in a given aircraft, it would be better. So the standardization around that is absolutely key, and ICAO has a key role for the standardization. And by the way, all what we are talking today are part of the GAMP. We are not reinventing the wheel. Huh? We are just playing with things which have been standardized for years. Now it's a matter of making them real. And then the roadmap to translate what is on the paper into reality is something which is needed, at least to agree locally and then globally on objective. If we don't know what are our objectives, we will be totally messed. And collaborations rely first on agreeing on the objectives and then on how to deploy them. This is where I think a roadmap is needed, not probably a worldwide, keep it simple, and then to make the aggregation of the different roadmaps that we will get.
Thank you. We're almost out of time. So Giancarlo, please.
Just 1 minute to say that if I look at why certain roadmaps on these topics have failed in Europe in the past, I think we should be looking at the right incentivization, which has always been an issue. And we also should be looking at enforcement. What do we do if somebody is not following the roadmap? And I think these two things needs to be very clear along the roadmap itself. Thank you.
Thank you. So we're ending the panel on the tone of enforcement. No. So I think it's been a really good discussion. I hope it's set the scene for the rest of the symposium. We're going to next have a presentation about the global TBO operational concept. And that will then take us into some of the real content related to TBO. I think this session has set ourselves a little bit of a challenge. We see what we need to do, apparently. We'll find out maybe in the coming couple of days if we all agree on what needs to be done, because the devil, I'm sure, is somewhere in the detail. But we have a direction we want to take. We think it shouldn't be as easy as it may be, sorry, as difficult as we maybe are making it, and we need to find ways of making it simpler. So I'd just like to conclude by thanking all of the panelists, the presenters, and I have the greatest pleasure to tell you all it's now time for a coffee break. Please be back at 4:15 sharp. We have online participants, so we have to have a strict departure time at 4:15 for the next session. Thank you. Okay, welcome back. Especially to those of you online, we're just waiting for people to return into the meeting room and then we will get started. So for session 2 of the symposium, as I mentioned before the break, we will have a presentation on the global TBO concept. And for that, I have great pleasure in introducing, it's going to be a double act, very dynamic, I'm told. So it's going to be a presentation by Crystal Kim, who's the who's the technical officer for airspace management and optimization in ICAO, and also serves as secretary of the ICAO ATM RPP panel. And Henk Hoff, who is the head of ICAO and concept at EUROCONTROL and is chairman of the ATM RPP. So without any further ado, I hand the floor to Crystal and Henk.
Okay, I think a few people are still coming in, so I'll go a little bit slow. Good afternoon, everyone. It is with my great pleasure to be here today. Personally, as a technical officer who's been working on the subject for over a decade, the TBO concept itself, and also several enabling capabilities that you are going to hear more about it during our presentation, namely FFIs and data link communication, 2 of the key technical enablers that will realize the TBO concept itself. And I wish to thank the 5 organizations who brought this global TBO symposium for the first time ever. I think we've already learned a lot about the TBO concept itself, and also a lot of great insights from the various stakeholders that we all understood everybody should bring their piece together to realize the TBO, either on a global or regional level. The previous session was a great lead-in session to our session 2, because the session really addressed the current limitations of an ATM system and also what are the benefits that TBO actually could bring. In this session 2, Mr. Henk Hoff, I just got the permission that I can call him Henk because I've been working with him over 10 years. So Henk and I wish to provide you with an additional context of the global TBO concept and the TBO capabilities and technical enablers, and also what are the current ongoing activities of an ICAO. I heard a lot of expectations that you are actually looking at for ICAO, bring this TBO global level, and also to accelerate faster deployment of the TBO capabilities. So just to give you a little bit of background, I also heard some of the presentation briefly mention about the very sacred document that we have, Global ATM Operational Concept. This document actually defined, oops, this goes too fast. This document actually defined what air traffic management constitutes, first time. And also this is one of the first operational concepts that ICAO ever developed in the wide range of the air traffic management. And this document gave the foundation for the enabling concept documents that are listed in this slide that has been developed by ICAO in the last 20 years. And also this GetMo provided the framework for the performance management and performance improvement. GetMo, together with this enabling concept documents, one of which is trajectory-based operation global concept, became again the foundation to support the global and the regional planning, which laid out the timelines. We also heard about the roadmap, not to the level that you wished for. However, it gave some insight on which time frame certain capabilities will be made available. This global planning drove the global standardization activity, which turned into the document called ICAO Annexes, Procedures for Air Navigation, and manuals or guidance material. TBO is not really new. This was already envisioned in the SCETMOC document, the key principles, which is the constant optimization of the trajectory with the advanced or readily available information, was already envisioned in this SCETMOC document, which is currently being revised again with the Air Traffic Management Requirements and Performance Panel that Henk and myself have been serving as a chair and the secretary in the past years. So this global TBO concept, where it is and what is the current status? This concept was presented to the Air Navigation Conference 13th in 2018, which received the broad support from the global community, not only from the regulators, but also from the industry partners. And that concept became the foundation for all the activities subsequently of an ICAO. Therefore, the concept had been integrated into Global Air Navigation Plan and Aviation System Block Upgrade. I think this is the time that I give the floor to Henk, who will talk about what happened since this air navigation conference.
You will have to applaud 4 times. We will have an interaction. So it's great to be here. Great to see this symposium after so many years. It's also absolutely great that I can deliver this together with Miss Kim, who I may call Crystal. And we both serve the ATM RPP, the ATM Requirements and Performance Panel. Many of the members of that great team are in this room. Can I have a show of hands, please? Yeah, okay. So if you have any questions about TBO, you can approach these people. They know all about it. Right, so ATM RPP. This is a picture that was developed a couple of years ago when we were talking about the Air Navigation Commission about TBO, the concept. And we as ATM RPP delivered this TBO concept. We maintained the global ATM operational concepts. We developed SWIM concept, connected aircraft concepts, and FFIs. And not only we developed FFI's concept, but also the detailed ICAO provisions. So we have our head in the clouds and our feet on the ground in order to do that work. That also refers to our approach, because when you develop a TBO operational concept, our dear airspace users, the ink is nearly dry. They will say, what are the benefits? And we turned this completely around. We said to the airspace users, well, you tell us which benefits you need, and you help us develop this TBO in a way that it delivers benefits. So for that reason, we combine our meetings often with visits to network operation centers. And we also have our tabletop exercises where we go through scenarios together with airline staff. You see here Air China. Recently we went to Seoul, where we had a session with Korean Airlines. Also IATA hosted a tabletop exercise with people from airlines present and participating. And these are very useful exercises to develop your approach and to develop it towards a solution that delivers benefits. So this is one of the scenarios just to illustrate that we put on the table. I won't go into detail because of time, but simply said, the blue line is the route that is put in the flight plan, today's flight plan. The aircraft is airborne. This is a real flight that took place from the west coast of the US to Tel Aviv. And the aircraft is airborne. Network operations, they get new wind data, and they figured out that they can fly much more efficiently flying the black line. Now, the question I ask when I present this to airlines, well, can you do this today? Can you change this route, the aircraft is airborne, to follow the black route? Well, some of them say, well, it's possible, but I have to make lots of phone calls. And, well, can you do it in a systematic way? They say, no, it's not possible to do that today in a systematic way. Do you want it? Yes, we want it. Well, there you go. What do we need to do in order to make this happen? Just one example, and there are many of these examples. So what we need is to continuously focus on flight efficiency. And basically what we need is to extend flight planning from pre-departure into post-departure. And that's exactly what TBO is all about. So how to make this happen? We need to go for that first to today's situation. TBO is a transformation. I heard that word for the first time before the break, only once. It's a transformation. This is what we have today, still to have today. It's an extrapolation of how we started air traffic management in the past. Very centered around voice communication. You see the actors, the flight crew, flight operations center, air traffic flow management, ATC, and they all interact with voice communication. They exchange information using voice communication merely. They all benefit by each actor from some automation. In one part of the world it's more, in one other part is less. And in some part of the world this automation is also connected. But this is not a situation you can extrapolate further into the future. This situation cannot respond to the traffic needs that we are facing. Because we have very limited coordination of the flight plan. The flight plan is filed, aircraft takes off, and well, the plan stays the plan, and it's further tactically handled. Well, and you see here all the issues associated with it. And basically what you have is an imprecise execution of the plan, and you don't have the predictability that we need in order to make it happen. That's the issue. In order to improve this, and now we are talking TBO and transformation, and this is really an important word I want to share with you, transformation. And it's really one of the, I also want to reduce and limit a bit the enthusiasm before the break. If we just continue this way and see TBO as, okay, we have a little bit more information and we can do some more automation, it won't work. We make the environments much more complex, and well, we hit a wall. So we need to do this, an information-centric approach. And the center here is shared consistent trajectories. And that are the first two words of TBO which are key. It's shared and maintained. And if you have everywhere between all actors shared and maintained flight information, and the 4D trajectory to be one of the centerpieces of that information, only then you can base automation on it. And you can use that automation for collaborative decision making. And that's, ladies and gentlemen, that is TBO. And that brings the benefits and nothing else. So it's important to not only talk about TBO as, okay, we are going to share some flight trajectories and we are going to maintain it, but we need to invest in automation. We need to make it better. Investing in automation means also that we have to dare to revisit the role of the human in this whole system. This role of the human is going to change because the information in the system will be mind-blowing. There's no human that will be capable to do anything with that information. You need to invest in automation, in innovation, artificial intelligence, machine learning, and what have you. And only then you can have the solutions that we want to see. We want to have improved control precision and accurate execution of the plan that was filed. So in summary, trajectory-based operation, there are three words really that define it. And I've heard that already. We were very pleased to see that the work is sort of moving forwards, is sharing the flight trajectory, flight information, maintaining it, and using it for collaborative decision-making. That are the three words that define trajectory-based operation. And flight and flow information for collaborative environments. As ATM-RPP, we developed the standards for that are effective and by now and will be implemented all over the world. We have in the Air Navigation Conference, there will be a paper on the sunset date of Flight Plan 2012. These are the first concrete steps towards TBO. Another concept, and we hear more about that also in this symposium, connected aircraft. We need to integrate the aircraft in this whole approach. It's part of the sharing of information. And that is in one slide what TBO is all about. This figure comes from the TBO concept document that we are working on still. And what you see, I'm also not going into details here, but you see on top scheduling, flight planning, and reoptimization. That's from an airline perspective. And the blue arrows indicate the instances where flight information can be exchanged and is of use for collaborative decision making. You see that starts for flow management, interacting with the arrival, departure airports, traffic synchronization. That's all part of the game. So the message here is TBO is ATM system-wide. It's an ATM transformation. There's not a TBO box somewhere sitting in a control room or an aircraft. It's system-wide, and it needs to be approached from a system-wide perspective. I think that's you now. Crystal.
Wow. What a good summary of the TBO concept in just less than 5 minutes. So now I'd like to drill down a little bit more into detail from the system perspective into a flight perspective, and then bring the flow aspect as well, how it actually fits together. So we've heard a lot of these words: negotiation, management, and optimization. So this is the key framework that really enables the optimization of the flight trajectory, single flight trajectory. Thanks to the system-wide information capability, we will have a better access to all sorts of information, the trajectory information itself, and all the other information that actually affect that trajectory. With that additional information, airspace users or the ATM services provider can offer re-optimization of the trajectory that you already agreed. And the re-optimized trajectory will be shared and maintained. Remember, shared and maintained across all the participants. And this trajectory will need to be delivered to the flight deck to allow the flight crew to proceed with that agreed trajectory through data link. Current data link can deliver that, but future data link will actually deliver more precise and robust clearance. So that's how TBO will work from the perspective of a single flight trajectory. Now, we won't have just one trajectory in the airspace, right? So there will be multiple millions of these trajectory, aggregation of this trajectory information, again, shared and maintained, will form the basis for the demand information. If this information is more available to all these ATFM actors, imagine how accurate, more accurate their demand estimation. Again, with the access to, better access to all the other information related to the capacity. The ATFM, again, will have a stronger tool to do the better capacity and demand and capacity balancing, which will allow to provide more robust ATFM solutions, which will, again, become the constraints or restrictions to the each flight trajectory. So this is the full cycle of flight trajectory together with the ATFM, how it's going to work in TBO environment. So constantly changing flow information will affect the flight information as well, vice versa. So how do we make this possible? This slide actually shows the type of capabilities that are mapped to a set of technical enablers. These technical enablers will not be really solving all the solution, all the problems that we have today, enabling the TBO. As Hank mentioned, in addition to these technical enablers, we will need enhanced automation to support better use of these capabilities. And also we do need revised operational procedures that will take into consideration new role of a human in the system. But we can't deliver all these capabilities overnight, all over the world. It's impossible. TBO is not meant to be a big bang approach. So these capabilities will evolve based on the operational needs in different parts of the world. So this slide shows you how it is going to evolve. Let's look at just the one aspect, flight information. Airspace user, we already have a mechanism that really exchange flight plan information. Somebody in our ATM-RPP always say it's a fire and forget. So today, flight plan, you submit and then leave it to the ANSPs to deliver best clearance. You have no idea what clearance you're going to receive. But with the introduction of the FFIs, you will be able to, you as an airspace user, be able to participate this constant negotiation and optimization of the trajectory, which will be shared through this flight deck. And trajectory accuracy. Yes, we do have an ADSB today, which will give an information on the flight state, current altitude, speed. And this information does give a better prediction for the ground system even today. However, with the advanced information that is going to be enabled by next generation of the ADSC and also other connected aircraft capabilities will allow this information exchange that is contained in the aircraft that will allow better synchronization between air and ground and help the ground system to do the better prediction. So yes, we have a better trajectory, better prediction. How do we clear? Today, most of the clearances are given by voice, and many parts of the world are moving towards data communication. Current CPDLC capability does give more detailed, precise clearances than the voice. However, there's next version around the corner. We also heard something called B2, right? Baseline 2, that will allow the precise TBO clearances. And there are other capabilities that are not listed in this slide that enables TBO, bringing all these pieces together. As I mentioned, these capabilities cannot be deployed and rolled out at the same time in the same place, which will inevitably lead us to mixed mode operation. Again, it's time to switch the speaker.
So transition, that's the final part and what we are doing at the moment in ICAO on TBO. Mixed mode and transition, Crystal said it already, there is no big bang here. There's not that we tomorrow have TBO. We develop it and approach it in ICAO and ATM-RPP in a performance-driven way. So every step we take should deliver something, should not be something just to add on and to invest, but should deliver something. So on the other side, it's also not a Wild West. This will also not be something like, well, here are the TBO specifications, this is your menu, and choose whatever you want from the menu. That will not work as well. And we have the global plan, the global air navigation plan, to lead us through this and to define what is needed in terms of minimal path and what are the capabilities that we need to define in order to maintain consistency, harmonization, interoperability, while delivering performance benefits. All these things are very important. So it's value driven, and eventually we'll see a transition where some parts in the world will move earlier to TBO, others will move later, but we all move to TBO in a converging way in order to come up to the same point. And it would be very good to focus on certain airspaces already. And for example, the North Atlantic would be a great airspace to implement TBO as a first step. Maybe there are other airspaces, but the North Atlantic would be a good airspace. There are aircraft with good levels of capabilities and airlines that are interested in it. I think the ANSPs around the North Atlantic are interested in it. So to take this first step is very crucial. We can talk years, 5, 10 years more about TBO, but at some point you need to take a first step with minimal specifications. And I think if you talk about an outcome of this symposium, that would be a good conclusion. So we continue in ICAO to work on TBO, of course, also driven by the outcome of the 13th Air Navigation Conference that said, okay, how can you give us more guidance how to implement TBO? So in ATM-RPP, we are working on the refinement of the concepts, especially on this point of implementation and defining the capabilities that we need both on the airborne side as well as on the ground side in order to make it happen, and which combination of capability will deliver benefits. That's all, sorry, that all goes in the Global Air Navigation Plan, not in this edition, but in future editions where we will see what the roadmap is. And here the word roadmap comes up, but then on a global level, what the path towards TBO can and should be in an interoperable and harmonized manner. And I said it again, I say it again, it's a value-driven support, not that the price is higher than the value, but the value is heavier than the price, so it goes down. And we do that with clear involvement and direct involvement of the direct stakeholders. It's not a sort of isolated exercise, it's really with these tabletops and so forth, it really helps us to develop this. Well, this is the end, this is the last slide. Again, I would like to emphasize the word transformation. It's a paradigm change. It has always been a heavy word, which is often misused, paradigm change. But this is a paradigm change. When I started to work in ICAO back in the 80s, this word and TBO was already sort of on the paper and being discussed. But now, really also because of technical innovation and advancements, we can make it happen. We can make this paradigm change happen if we approach it as a transformation. And there's a good example in nature of transformation, and this is this caterpillar. So if this caterpillar wants to walk faster, you can give it more feet or make it bigger, but that's not really transformation. We should not continue to today's way of doing air traffic management. We need to think outside the box. And like this caterpillar, we need to dream and believe we can fly, and then we get wings and we have a real transformation. And that's the same for TBO. We need to invest in automation, address the role of the human, and look at processes in an involved stakeholder way. So on behalf of Crystal and myself, I really thank you for your attention.
Thank you very much, Crystal and Henk. You did a great job covering a lot of ground in a limited time. If you have questions, keep them. There's a networking drink later, and Henk and Crystal, I think, may be around. So we're going to move on to the next session, which is about experience from research. And for that, I have the great pleasure to introduce Sven Hall from the ICAO Paris office, where he is, amongst other things, in charge of Europe, North America traffic flows involving as many as 56 states. So Sven, please come and introduce your session. Thank you.
Thank you very much, David. It's a great pleasure for me to moderate now the session 3, which brings from the global ICAO perspective now a perspective on the experience from the TBO research and innovation from the 3 regions we have here. We have speakers, very good speakers, covering TBO research activities in Europe, North America, and also Asia Pacific. And I would like to introduce to you, in order of presenting, the 3 speakers. We start with Olivia Nunes from the SESAR Joint Undertaking. Olivia has been an aviation professional for over 30 years, and after 20 years of operation experience as an en route and approach controller, she joined the SJU to work in R&D. She has now head of the technology and master planning at the SESAR 3 Joint Undertaking, and she has been the TBO expert since more than 10 years. And then I continue with Steve Redford from the Federal Aviation Administration. Steve is the chief scientist for architecture and next-gen development in the FAA. He has been working on international concepts and research into trajectory operations from the days of the EUROCONTROL's FAR and the FAA's free flight in the late 90s, and followed by the GATMOC and continued into cooperation between NextGen and SESAR. Next in line would be Peter Alti. Pete is a program and project manager we know from EUROCONTROL for a long time. He had already been in RVSM and Link 2000 plus CPDLC programs and worked as a program manager for 833 channel spacing deployment. He joined the SESAR joint undertaking as a secondee, and he worked on different projects addressing network management, flight operations, MET info services, and since rejoining EUROCONTROL in 2017, he's now the project coordinator for SESAR research and innovation projects addressing TBO operations in the flight execution phase. And he will have a joint presentation with Gérard Mavoujan. Gérard is leading the SESAR 3 network TBO project at EUROCONTROL and in the INO unit. He started his career as DSNA in R&D, and he is since 2001 with EUROCONTROL the R&D manager in trajectory management, flight planning, and ATFM domains. So a big wealth of information here. And then last but not least, we have Amonrat Girati Galashot. I'm not telling that name again. I just called her Amo. Amo is currently working for Aerotai in the position as strategic planning manager in the engineering team. Since 2013, she has been responsible for strategic planning and conducting study and analysis on new operational concept technologies for Aerotai. Her focus is on the modernization of R&D developments and future air navigation concept such as TBO, and she was already on the screen at the presentation when we talked about the Asia Pacific flights. So without further delay, I will introduce Olivia to talk on the R&D perspective, and we have a Q&A session at the end. So please hold your questions until we have heard from the 5 outstanding presenters on what they have to tell us on their research experience. Olivia.
So thank you, Sven. Hello, everybody. I'll try to give a very brief account of the research we have done in SESAR. The SESAR program has been researching TBO for about 15 years, so since the very start. I feel a bit embarrassed about my first slide because you're going to say, oh, someone again telling us what TBO is. Just to say that the TBO research in SESAR has addressed all phases of flight, and actually it's a strategic, tactical, pre-departure, post-departure. So if I think maybe sometimes there is this misconception that TBO is only strategic. It's actually, at least from the SESAR perspective, it has not been like that at all. The objective is to address optimization all along the trajectory flight cycle in all phases of flight. It is not something that we can expect will take away the need to manage flights tactically by ATC. That's not the case at all. And actually what we want is to integrate all trajectory management processes, not like today, as we saw earlier in the slides, where everyone is doing their own thing to the trajectory and trajectories do not match. So just to say that it is essential to have increased air-ground connectivity. TBO relies on exchange of information between ground partners and as well between air and ground. And just to be clear, what we have today will not do. So we will need to have increased bandwidth air-ground. But that's not what I'm going to talk about. We already have a lot of research in that area in SESAR, but more about the operational concept and what we have done in the research towards making this trajectory optimization a reality. There is already has been mentioned, a huge connection between automation and TBO. So TBO is not possible without automation, and the reverse, actually TBO is an enabler for increased automation. So it's a two-way relationship. And it actually refers to the automation in ATM, also in the Airline Flight Operations Center, ATC. So all actors need to increase their level of automation if they're going to participate in TBO. So really quickly, just very similar slide, but with different layout. But to say, The TBO research that we have, we kind of have it structured around three main axes. As you know, in Europe, we have the ATM service provision divided into what we call the network manager and the ANSPs. And they have distinct functions that are established in the regulation. And so basically all the flight planning, ATFM, is done by the network manager that we refer to as network TBO, connecting directly to the flight operation center. Then the flight deck is going to be connected to ATC, and that we refer to as ATC TBO. We actually have done research on this for a long time. Now we have specifically projects that are addressing, and they're called Network TBO and ATC TBO, and they will be presenting on their ongoing research just in a moment. And then we also have a lot of work about aligning ground partners, so between the network manager and the INSPs, which is really important. It's not just between, let's say, because in Europe we have this setup, it also affects coordination between different air service ASPs, air traffic service providers, in between different regions. So the process is not exclusive to Europe. We do refer them, probably not a great name, as regional network alignment. It also addresses the incorporation of the airports into the network. So all these CDM processes that are going to provide better estimates, let's say at what time the aircraft is actually going to take off, the wheels of time, which is essential to improve the planning, are also included here, as well as the sharing of arrival planning information with airports. So I'm going to start. We've heard a lot about FFIs. To say FFIs is, as many of you probably know, mandated in Europe. And we are moving. The network manager has already implemented the FFIs in flight plan in the network manager systems. Why this change? First thing I want to say is not just a format change. It is true that the Flight Plan 2012 is a different format. It's actually the last form-based format for the flight plan. The EFPL, the new flight plan, the FFI's flight plan is machine readable and is going to be much easier to treat for automated systems. But it's like when you buy when we all move to smartphones, it's not just about calling. You know, you can do a lot more. And I do like this analogy. If all you put in the FFI's flight plan is the same that you put before, and you don't use the new processes, then you will not get the benefit. Okay, so you need to take a step. So just implementing it is not just about changing the format. You have to use the new processes. You have to add the information that can be added. And I would say in Europe, you know, when you first buy a new gadget, a new phone, you have an idea. I want to take pictures. I want to. So what the first validations, let's say, looked at the increase in the level of acceptance of flight plans. You know, we have a pretty complicated process, very well managed by the network manager in terms of flight plan acceptance in Europe. And thanks to the FFI's flight plan, if the airlines provide additional data, then the rate of automatic acceptance of flight plans increases. That's a very first benefit. Flight plans that are not automatically accepted are sorted out for manual processing. That's increased workload for everybody. But I would be lying if I said that's all about FFIs. We know that there's a lot more coming. This is just the pre-departure flight plan acceptance. The real power of FFIs is going to come later, and I think Gerard from the Network TBO project will be explaining more on what's going on in terms of research, and what we're expecting will come in actually not a long time, because the first step has already been taken. Next, I want to talk about kind of a disappointment we had. We had a lot of research at the beginning of SESAR on the use of airborne time constraints. So this refers to the use by the avionics of the required time of arrival function. We even have increased precision. And actually, things really didn't work out. It's also true that the world changed around us. So when we started the research, aircraft were not flying with as slow low cost indexes as they do before, and there was a possibility to speed up and slow down, which today does not really exist. I think we have all learned that it's better to fly slower from the point of view of the environment. So really, there is very little margin for doing some delay absorption by slowing down. Then the use of this time constraints in terms of the ATFM functions didn't work as either, because really our big unpredictability in Europe is in the vertical domain, the sector penetration. We have a lot of sectors that are sliced vertically. And in fact, in practice, it's also true that when you have a lot of traffic, you don't care so much about the specific time that the aircraft will get into the sector, because there's kind of a normal distribution. Some are late, some are early, and they compensate each other a bit. So that's actually, after all this research, came with the idea, to the conclusion that it's actually not the way to go. So the way to go, the answer for us is ATSB2. So the idea is that the flight crew can manage the flight path, we know, in different ways, using either the autopilot and the FMS. We can get direct information. We already got it from the autopilot through the SESAR downlink, but now we can get from the FMS the ADSC downlink. And this dialogue between ATM systems and the flight deck that's looking directly at the flight path control is what we have seen has huge possibilities in terms of automation and of optimization on both sides, on the ground and in the air, strategic and tactical. In addition, the FMS is not the only computer on board. So there are more computers on board, several. I put here the electronic flight bag. For us is anything that's not managing the flight path. And therefore, we'll have a faster update, of a cycle update. And this is actually a new development priority for us, to see how we are going to complement the downlink of the trajectory and the CPDLC with the additional data that's coming from the EFB or other computers that do not manage the flight path. I put a few things in here. I don't want to really read, but this is all exploratory for us. And like I say, a new priority. Very briefly about what I was referring to as regional, to say that actually the same principles do apply between ASPs. And we think it's obviously interesting for everybody. It may not require the same degree of harmonization. This refers to the sharing of estimates across borders, to the update from the airports into the network. But without it, we would not have TBO. So it is necessary to have this actual exchange of information between ground partners all the time. And as we know today, this is not the case. Many times, once the flight plan is filed, if an aircraft is delayed by 10 minutes, you will not know anything until you actually get the estimate. And this, we want to change this. We have also, just to say, it's very connected as well to the connectivity of systems between different vendors on the ground. And it is aligned with our strategy to move towards service orientation, new business models, cloud-based systems. And so this is all a challenge for the ATM system. We think there is no room for monolithic systems anymore. And that's all. I don't want to repeat myself, just what has been said. TBO is about collaboration. We do have a lot of research results and materials. They're all public, and there are links. So just do visit our website. We have solution data packs for all our TBO solutions, of which we have many. And to say that, thank you very much for being here. I give the floor to Sven again, or Steve, I don't know.
So I'm back again. So I'm going to take a little bit different approach to our experience in our innovation, and talk to you a little bit about how we may be doing more of a pivot in our research recently. So everybody had to have a slide about what is TBO. So here's my definition. This makes the briefing self-contained, but you don't have to read this. This is how we've been operationalizing next-gen in terms of TBO. We've been working on our infrastructure. We delivered the last pieces of our infrastructure last year, 2 years late because of COVID, and that was our surface manager, our D-man, or S-man, excuse me, trying to use the more ICAO terminology. We have both a network manager, which is our TFMS system out at our command center, which works across the country and in all the major airports in the centers. We have our time-based flow management system, which is at all of our centers. I think it's up to 50 airports have been implemented for time-based flow management. So that's really our initial TBO. One of the aspects there is that the trajectory, while it is trajectory based, it is airport by airport trajectory based. We're not using, sharing, and managing a single trajectory. Every one of our systems has its own trajectory. So our network manager tool, our TFMS, has a trajectory. Our separation tool has a trajectory. Our time-based flow management has a trajectory, and they may or may not agree. And every aircraft out there, where's Mr. Altus, that has a trajectory, and they probably don't agree. And then we've been working on we've been able to integrate some of our tools and get a little bit more towards that. So we've got our terminal flight data manager, which is our S-man, does integrate a little bit with our time-based flow management. One of the great mysteries of life in the United States is that you have to be arriving someplace before you can depart. And that's very tactical. It's not pre-planned in the United States. So if you want to leave Dulles, our national airport, you go to LaGuardia or to Charlotte, the first thing you have to do is request approval to leave, meaning we give you a time to get there. So our traffic flow management is often based on arriving before you depart, because the East Coast is just so dense. And so we've been doing some of that in full dynamic. Dynamic really requires the next step. And oh God, I got pretty much the same thing here. But anyways, here's some of the applications. The blue ones we've got going. The black ones are planted in research, and you'll see the phases of flight we've been working on. You'll see that we're not completely done, but we've implemented quite a few things to support trajectory-based operations. But I'm here to tell you that we do not have trajectory-based operations in terms of the ICAO definition. So this is my favorite slide of this. These are all the actors in the United States that interact with a flight, and we have all the different types of interactions. We have, in the different separation management, trajectory management, flow management. The key here is that at no time do all the automation systems agree on what's going to happen. So, case in point, and Olivia brought this up, if you're flying along and a controller gives you a vector for traffic or for flow convenience, the controller knows what the pilot's good at, what the aircraft is now, but the ground automation doesn't know what the trajectory is. The pilot's taking the instruction and he's going, okay, I kind of know where I'm going, but he hasn't probably been given a turn back, so he has sort of a partial view of what the trajectory will be. The flight deck has no idea. The FMS has no idea where it's going, but it has all these heuristics to keep guessing. And my ground system does the same thing. As long as we have voice and interactions that do not capture the information, we always have disconnects in our trajectory. So it's not just our decision support tools, it's even in our tactical. And if you're on a vector long enough, it's going to screw up the plan and its separation and everything else. So that's what it is today. And this is what we really want to do. We really want the automation. Humans can still make the decision, but we want the automation to be sharing the decisions all the way around. So there's a common trajectory. So we're sharing, managing, and using the common trajectory, whether it's for separation, whether it's for synchronization, or whether it's for traffic, it's for flow purposes and or demand capacity balancing. So this is our goal. And this is what we've been working on the last couple of years is we've implemented as far as we probably can with our decision support tools without moving the next step and really getting the information. So I talked about that before, if information sharing and synchronizing the information across the automation systems so the actors are all synchronized is very, very important. And I just wanted to bring up two things we're currently working on. I don't want to go into a lot of detail because I'm almost going to do one of them. Clearly, we've been involved in connected aircraft for a long time. And so our viewpoint is that we can go from treating it as a supplemental source of information or negotiations. We do believe, and we have demonstrated, that we can safely and securely put instructions to the EFB from the ground and put it on the second page of the FMS. Now, we have a lot of work to do, but using other people's spectrum doesn't seem to be a hindrance in order to furthering. So we spend a lot of time on non-safety critical connected aircraft. We really need to look also at the safety critical aspects because our spectrum is full. So that's one of the things we're doing and we've been demonstrating. I want to bring up two demonstrations, then I'm going to turn it over to the other people. The one demonstration is what we call CADI, Connected Aircraft Trajectory Information. We're looking at using the commercial data link to share aircraft intent, trajectory negotiations, and clearance delivery. We've been looking at how you can get information off the aircraft as part of multi-region TBO, and I'm going to look at AMO here in a second. We downlinked to the EFB, was it every minute? Yeah, every minute over Inmarsat, information off the EFB. So we actually not only were tracking the position, but we're tracking the state of both the atmosphere and the aircraft across the Pacific as we were doing our multi-region TBO. The key there was that we had a certain set of parameters. Now we're going into what parameters can we get and how can we better use those parameters for predicting and sharing the trajectory. And so that's CADI. The second thing is the one that Amo's going to talk about, which is the multi-region TBO, which was really, we weren't proving FFICE R1. R1 didn't involve any aircraft. This version involved aircraft. So we were looking at how we can share the flight information, ANSP to ANSP, and with the flight deck. And the key here is that this research allows us to, in a true operational sense, test the messages, test the formats, test the information exchanges of R2. And that's what we really want to do. We want to advance. How do we do R2? Do we have the right messages? Do we have the right information exchanges? And we want to advance how we can get better information to build the trajectories. Not working on any more decision support tools right at the moment for a lot of reasons. One is budget. We probably can't get back to some of our decision support tools till 2029, but we can spend our time really building out the enablers, which are important for us to move on to the next phase of our TBO journey. And with that, I'll give it back to you, David, so you can introduce the other people. Oh, no, Sven, sorry. I'll give it back to you, Sven.
No, thank you. Gerard.
Okay. So I'll quick go to the next one. Okay. So good afternoon, everybody, almost good evening. So Peter Alty and I, we will present you some SESAR project related to TBO. So since TBO is quite wide, we are split it in two main projects. Network TBO is addressing all TBO related to network management, where ATC TBO is more focusing or tactical ATC operation and CPDLC, that kind of thing. Now starting with network TBO. The main problem we are addressing is that in current operation, these actors, the network manager, ATC, flight operation center, and payload, have really a different view of the planned trajectory. And this creates a lot of inefficiencies, both in pre-departure and post-departure phases. And the problem is not so easy to solve, in fact, because there are different perspectives, different opinions, and most of these actors are part of the information. That's why the project is a lot about trajectory information sharing, but it is also about setting some collaborative processes in order to agree on a trajectory to share. Now, the stakeholders of this project, Network TBO. Of course, we have the network manager, which is positioned to provide future services and even current services in support to TBO and count on the project to progress on the less mature aspects. You have, of course, also INSPs that are very interested by network services, in particular to improve coordination, trajectory coordination with airspace users and other INSPs. You have ATC industry as well, very interested by network services and data to improve local trajectory management services. You have airspace users, which expect from the project less constraints and more flexibility, and also very interested by our link with ICAO, because they are very interested by globally standardized solution, not limited to Europe. And to finish, we have IU industry, what I call IU industry. In fact, they are involved in the project and very interested because they see new business opportunities, in particular develop new trajectory optimization and negotiation function, both for pilots and dispatchers. So now the project structure. So it's a project first that it is a 3 years project that started in September 2023. And it's divided into what we call 3 main solutions. So solution 1 is related to pre-departure phase. So it's strongly linked to FFI's release 1 and include 2 main topics, one being the better integration of plan ATC constraint in the high flight planning and FMS. And the second topic is the notion of primary flight plan, which is also coming from FFI's release 1. The solution 2 is focusing on strategic execution, so strongly related to FFI's release 2. And it's about trajectory vision in execution, not involving tactical ATC, either on FOG, pilot, or ATCM initiative. And solution 3, which is called trajectory synchronization is execution, is mainly focusing on improving network trajectory prediction, including some new information coming either from the ACCs, in particular ACC coordination info, or from the aircraft. As you can see, it's quite an important project. You have 22 partners plus 8 organizations in the advisory board. This slide shows also that we are far from doing this project in isolation. Obviously, we have strong links in SESAR with ATC TBO project, but also with 2 Green Deal projects for which network TBO is an important enabler. We have strong links with the network manager and some implementation projects. Strong links thanks to Hank with ICAO and in particular the ATM-RPP working group, which is dealing with FFIs and connected aircraft. And this is topics we are addressing intensively in the project. And also we are linked in particular in the context of the solution 3 with the deployment manager and the working group dealing with TB IOP. This slide is quite important to show the close link between our R&D activity, implementation, and standardization. In 7 minutes, I have no time to go, of course, in each topic description. This slide is only to advertise about a very interesting demo we are presenting at the SESAR TBO stand. It's related to the pre-departure phase, and so related also to FFI's release 1. And it's a demo on using a machine learning model to provide, let's say, enrich information to the airspace users on ATC constraint. A quick focus on the solution 2 about strategic execution and FFI's release 2, because this is really what it is quite new and will become more and more important in the incoming years. So as I said, our activity is strongly related to ICAO FFI's release 2 developments. In the last 2 years, we were more in the initial phase of definitions of the processes, role and responsibilities, and so on. So we developed what we call 2 European tabletops involving a wide range of operational experts in 2022 and 2023. And also, it was already mentioned, I think, by Hank, that we organize a joint tabletop with FAA, IATA, and NAV Canada to address interregional scenarios. And now in the project, we are really entering in the concrete phase of prototyping that FFI's Release 2 services in order to do some validation next year with the consortium partners. Additionally, what we would like to do in the following months is to organize additional tabletops, in particular to reinforce some cooperation with the other ICAO region, and also to address some new use case, for example, related to the Green Deal projects. This last slide is so as I mentioned, it's a 3-year project, so it will finish in 2026, and these slides provide a view beyond that to 2026. So for solution 1 and 3, it's quite clear. We expect to achieve the maturity to go in implementation. So normally everything should go in industrialization. What will go probably the quicker in implementation is in solution 3, the use of EPP information in NM, because this is beyond, this is under the CP1 regulation and deadline in 2027. For solution 2 and FFI's Release 2, here we have a more longer term perspective. So normally the industrial research will continue until 2029, but we would like to start in 2026 some demonstration or trial for the more mature services. And now I give you the floor, Peter.
So according to the, I have 10 minutes. Wow, that's not bad. Before it was 2 minutes, okay. So before I give my presentation, I'm going to do a plug, okay. There's been a lot of PowerPoint this afternoon. In the lobby, there are some extremely good exhibitions. Please, when you get your drink, walk around the lobby, visit the demonstration stands. You will learn a lot more than you will by listening to me, okay? All right. So the ATC TBO, the first thing I want to do, I just want to highlight the difference between the project which has been presented by Gerard and the project which I'm leading. In an ideal world, it would be one project, but the world is quite complicated, okay? Basically, we're looking at the tactical execution part, okay? Network TBO is looking at the planning, everything up to pre-departure. It's looking at strategic execution. This is more about collaborative decision-making in the flight execution phase. And we are very much looking at the coordination and separation horizon of the executive and the planning controller. So we're looking at the 2 key stakeholders here are the flight crew and the controllers, absolutely key. So ATM aims to optimize the network performance whilst doing the best that we can to minimize deviation from the airspace users' requested trajectories. And we have 2 airspace users here, okay? But we know that those trajectories may need to change in flights. Crossing traffic, weather hazards, arrival procedures, airspace user operational needs, shit just happens, okay? So the ATC TBO is validating use cases that provide flexibility to deal with uncertainty in the flight execution phase, okay? Now, the use case example I'm going to give you is explained much better outside, okay? But the problem, we have uncertainty. We have a lack of accuracy in the trajectory. And this means that we have to do level ops. It means that in our conflict detection tools, sometimes we get false alerts, okay? So getting an accurate trajectory is really important, okay? Now, I heard Todd mention the EFB as an industrial research project coordinator. This project is using ADS-C EPP. So one of the main things we're using is that we're taking the predicted trajectory from the flight management system as calculated by the flight management system, and we're downloading the extended projected profile via ADS-C to the ground, okay? And what that's doing is, that's giving us a lot of additional information about the trajectory, okay? That's clear. We've heard the term automation used today. Well, we have in our validations, we're looking at automation, which gives us the opportunity to actually look at potential conflicts. The enhanced trajectory accuracy is giving us less false alerts. And when we look at potential clearances, to overcome those conflicts, machine learning, etc., is giving us the opportunity to say, what is the best trajectory? What is the best clearance in terms of, for example, fuel emission? What is the best trajectory based on what the controllers would accept, okay? And the CPDLC is the means by which we deliver the clearance to the aircraft, okay? Now, in terms of automation, the flight crew is really key, and the aspect of auto load for a complex clearance is key, certainly there. So I already did the plug for the demo in the lobby, but please just do it, okay? Now, on the right-hand side, you see a lot of validation exercises which have taken place over a kind of 2 to 3 year period, okay? So the concept that you've seen, we've had controllers working on industry platforms, working at the EUROCONTROL Innovation Hub in Brittany. In the case of Brittany, we've had the Toulouse A330 simulator linked to the simulator in Brittany. And we've had the controllers working on these scenarios. And the different use cases that they've looked at, the first use case is really about all of the benefits you get in terms of the enhanced trajectory prediction accuracy, the conflict detection and resolution, and we've also done some work on alerting adverse weather areas. We have the notion of the CPDLC complex clearances. That's lateral, issued downstream, vertical with non-penalizing constraints, and conformance monitoring. Complex is a word that scares some people, okay? But when you look in the dictionary, I like the definition which says it is multiple related elements, okay? So we're looking, for example, climb flight level 350, cross along the waypoint at flight 330. So it's complex, but we're talking about multiple messages, okay? In terms of the scenarios that we've worked on, in terms of the scenarios that these controllers have worked on Europe-wide, we've looked at increasing traffic and we've looked at different rates of HSB2 equipage. Razvan mentioned a figure this morning for 2035. We've simulated 2035. I don't believe, and I'm looking at the members of the team, I don't believe we simulated 50,000 flights per day in 2035, but we certainly increased the traffic, okay? And we looked at different rates of HSB2 equipage. Now, in terms of what the conclusions are, and as a former 833 kHz program manager, which was deployed, I'm very cautious with conclusions and recommendations. Very cautious indeed, okay? The work that we've performed has shown that this is operationally feasible, the concepts and the enablers. We have improved trajectory prediction, and that gives us a much more reliable detection envelope. We see that the lateral and vertical complex CPDLC clearances enables ATCO workload reduction and increased capacity. And that is especially the case when we combine the clearances with the enhanced TP accuracy use cases. Now, we're quite fortunate in the project in that tomorrow, I think you will get a presentation from Peter Hendricks of Maastricht. We have Maastricht controllers working with us, and that really helps us. It gives us an indication of the reality in terms of operations. And we can see that what the work that we're doing, the conclusions and recommendations that we have are in line with the SESAR large-scale demos and the in-the-field experience of Maastricht. If you want to get information, detailed information about what we have in terms of deliverables from the past, if you Google 4D Skyways deliverables, you will find the deliverables. At least I do. Or maybe I've got some really weird cookies, I don't know, okay? But just do it and it'll tell you how to use it. It's all there, all the evidence is there, okay? So, SESAR 3 ambitions. It's more difficult than a PowerPoint. When you go through the proposals, the grant agreements, everything, getting this all together is quite challenging, okay? But we have basically a number of SESAR solutions. What is a SESAR solution? A SESAR solution is a package of enablers and operational improvements that provides ATM benefits, and we validate it to see its readiness for market take-up. Looking on the right-hand side, we have two solutions which are really continuing the work that we've done before. We need to complete the validation of the operational and technical integration to assess a TRL6 maturity. And it's really important we engage with airspace users, NSPs and industry to align the expectations on the benefits and the operational acceptability to facilitate deployment. We also have a solution 6, which is looking at more future TBO concepts, and it's looking at automation. But the difference is we're looking at automation, which it is the automation which initiates the actions, okay? A lot of what we're doing now is assisting the controller, but the automation to actually initiate the action is really key there. And we have a large number of consortium members, and as EUROCONTROL, the project coordinator, of course, I gave us the biggest symbol, okay? So, good. We need to focus on value. So we need to make sure that we're invalidating the environment, the capacity, the operational efficiency, the cost efficiency, the safety, and the security benefits. And we have got a great team of people working on this. We just have one missing ingredient, okay? And the intention is to have the validation reports, performance assessments, the safety, the human performance, the security assessments, and the CBAs, which are available and accessible and concrete, okay? Now, the title of this session is Experience from Research and Innovation. So I'm going to highlight to you some key insights from the work we've done so far and key insights that need to be taken into account in the future work. And this is, and I say key, these are really key. And all of these insights have been taken from the material which has been reviewed and approved by the partners, okay? Now, the first point is that the benefits are strongly linked to the rate of the ATSB2 equipage, okay? I think in our best scenarios, we estimated 42% of the affected fleet equipped and 80% of the traffic equipped. And that was giving us, and I'm very conservative, that was giving us capacity benefits of 7 to 12%, okay? And I know that some controllers, some of the other individuals said, hey, we can do much better than that, but those are the conservative figures that we identified. The communications is really key. There's a lot of discussion about VHF VDL mode 2. In our simulations, we've used assumptions in terms of the latency. We've used assumptions in terms of the timeouts. We believe there is a lot more to offer still in VDL mode 2, but the current teams at EUROCONTROL, I think Veronica will give you a presentation tomorrow. They're working on getting the best out of that current system, but we need to look at other opportunities, SATCOM, for example, okay? And then I move to perhaps what I think is the most significant thing that we need to address. And this is the validation of the complexity and the workload in the cockpit. The relationship between the controllers, between the messages that we send, the clearances, and how that is handled in the cockpit, the way that constraints are handled in the FMS, the way that the speed, heading, altitude, flight level is handled, that's really key. So I cannot stress enough that the complexity in the workload in the cockpit is key, and the training of the awareness is really key as well. And so it's absolutely vital that we have a strong ATCO and flight crew involvement in the project. And this is really important to get trust, especially for the automation aspects. I'm very pleased to see that we had a European Cockpit Association representative here earlier. Okay, he was sitting next to the Airbus guys. I think he may have gone. I don't know if Like is still here. Okay, next to the Airbus guys. So this is good. Okay, and I think we had Eugenio from IFATCA. Okay, okay, good. So we need you guys on board, and we need you working in the project. It's absolutely key. Okay, because if you buy it, then ICAO, SGU, SDM, everybody else will buy it too, okay? So that's really key. Thank you for listening. On behalf of Gerard and myself, I just wanted to highlight the fact that, you know, I'm not so keen on social media, but we have to do it, okay? If you want to know more about the project and what's happening, we have the LinkedIn sites, Network TBO, and the ATC TBO. The point is that if you
access those sites. We will tell you what's going on and we'll give you access to the best information that we have. Thank you.
Good afternoon, everyone. My name is Amonrat Jiratikalashoth. Anybody get that? But at least when pronounce is very right. Thank you for that. You all can call me Amo for easier reference. First of all, I would like to thank all the organizers for providing us an opportunity to be with you today. Basically, today I'm going to provide you an overview of the joint project led by the US FAA together with the several organizations within Asia Pacific and also our industrial partner. And that include my organization, Airlines and Navigation Service Provider, Japan Civil Aviation Bureau, NSP of Japan, CAA Singapore, NAV Canada, and our industry partner, Boeing. And the main idea for us to put together this project is to validate and demonstrate the TBO concept, the document being developed by the ICAO ATM requirements and performance panels, as mentioned by Crystal and Hank earlier. And also, we would like to find opportunity for us to explore the impact of TBO within the context of modernization initiatives, and also to support the development of information exchange model and standards, as mentioned by Steve, which is a very key enabler for us to achieve TBO, and also to provide our feedback to support the development of related ICAO provisions. Our project's actually starting since 2020, and it's just complete itself in June 2023, so last year, with the light flight demonstration. We have divided our projects into phases. The first one, we focus on planning our activities, extending our partnerships, and also laying down the baseline technical capabilities that we need to achieve the TBO. And starting from 2021, we focus ourselves more on the execution of the multi-regional TBO demonstration. And for the first phase, for the first part of the phase 2, we were doing our lab demonstration, trying to develop more the technical capability needed for TBO and start establishing the system test and connectivity for ground system connection. And starting from 2022 to 2023, that's where we put our resources on the light flight demonstration, and we add more ingredient to our test bed with air-ground system connectivity as well. And we are trying to understand how we can make use of the existing equipment in the modern aircraft, and how we can make a use of a flexible device that we have on the aircraft right now to achieve TBO. And in June last year, the second week of June 11 to 16 June 2023, we completed the light flight demonstration, and we ran the flight for the 4 route segment, starting from Seattle to Tokyo, and then flying from Tokyo to Singapore, while overflying also Bangkok Flight Information Region. And the third segment included the flight from Singapore back to Bangkok, and we conclude our demonstration from Bangkok back to Seattle. I also would like to highlight that during that week, a series of activities were also conducted in different countries, starting from USA, Japan, Singapore, and Thailand, with our aim to foster a better understanding about TBO with our local stakeholder and our regional stakeholder as well. And within that light flight demo week, we also talk and provide opportunity also for our high-level management or the policy maker from the Ministry of Transport to visit the aircraft, observe the light flight demonstration while we are doing it. That really highlight the importance of the policy level support in driving the implementation of TBO. And if you are interested more on how we are doing that, you can follow the link that I provide in the bottom of the screen. That is a video that's going to provide you more information about the live flight demonstration. And with the conclusion of the live flight demonstration in June last year, I'm happy to share with you that we are able to put our pen on the report and saying that we be able to demonstrate all these operational values as shown on the slide, starting from the enhanced predictability with the common plan or common strategy that we share among ATM stakeholders. It can help enhance predictability, also improve the operations by mitigating the confusion among ourselves. And also with the sharing management and using of the trajectory as a common reference among us, we would be able to create a better alignment of strategic plan and tactical actions, provide more flexibility to accommodate the trajectory changes, while at the same time help our airspace user to maintain their business objectives. And last but not least, with the better trajectory accuracy that we share among us, it can help decrease the uncertainty in our air navigation system. And with all those operational value that we demonstrated, we rely ourselves on the operational capabilities and technical capabilities as I listed down on this slide, starting from the pre-departure trajectory, negotiation, planning, filing, until the point where we will be able to do the post-departure trajectory negotiation and revision. We also put ourselves, focus ourselves on how we are going to put together a better seamless information sharing among ATM stakeholders, and that's not only the sharing of constraint information, but also the trajectory update as well. And how we are going to have a better or enhanced collaborative decision making among ATM stakeholders, not only between ANSP and ANSP, but also between ANSP and also the airspace user. And with that, to enable all that operational capabilities, the technical capabilities that we develop, mature, and demonstrate during our activities that also include, as what mentioned earlier as well, the FFI Release 1 services for the pre-departure trajectory planning and negotiations. And we also do some part of the initial FFI Release 2 services around the airspace user to negotiate the trajectory change where the aircraft is already airborne. And we demonstrate the use of a connected aircraft, CPDLC, to also deliver the clearance. And we do all that over stream technical infrastructure using the stream information services. And also within this project, we take into account the trust framework being developed by another panel of the ICAO to also demonstrate how we can securely exchange the information among ourselves to ensure that the information that we share among us is not tempered along the way. And here I like to offer you the key lessons that we have learned within our project. There is a long list in the report that we have, but here are the 3 significant lessons learned that I like to share with you. It's like a repeat of all the speakers before me. TBO is all about the sharing, maintaining, and using trajectory as a common reference across stakeholders. However, within the project, we also learned that we still need to put more effort and work on how we are going to integrate the strategic planning and tactical reactions. And when we start talking about the post-departure airborne trajectory negotiation, how we are going to manage that with the downstream ANSP when the flight change its trajectory in the upstream ANSP. So all that need to be refined further. Another thing that is of the highlight of the lesson that we learned is how important the globally standardized information exchange model is for the success of TBO implementation. Basically, we need to speak using the same language. Like now, I need to speak English to you. I cannot speak Thai to you. Otherwise, you will not understand what I mean by doing all this project. So that's the importance of why we do need to have a standardized data models for that. We need to speak of the same language. And last but not least, we still need a continued evolution for the connected aircraft so that we could allow more active participants of the flight crew in the collaborative decision-making process. We provide them with more information so they can participate in how they wish to operate their flight as well. And that's all for me for now. Thank you very much.
So big thank you again to all the speakers. And now you have a very unique opportunity. You have excellent speakers that have given very good presentation, questions and answers to all the speakers. So I would like to open the floor for any question that you would have that we would like to address to the speakers that have talked about their experience on TBO R&D. Yes, please.
Oh, sorry. Thank you. My name is Regula Dettlingotte. I used to be the chair of the PRB, and so the question will not surprise some of you in the room. What is the expected increase in performance of this TBO project? So in terms of safety, in terms of environmental efficiency, in terms of capacity. We heard somebody mentioning performance and capacity increase. And last but not least, also in terms of cost.
Pete.
Yeah, thanks for the questions. I think I'd like to phone a friend to give you the answer, actually. Okay. So I'm just going to highlight the key points. What we've worked on are simulations, and we've basically validated with the controllers, and then our performance experts, such as Christian in front of you. Okay. And I don't know if Antonio Silis is here, our CBA experts, they've extrapolated that information. Okay. Just the headlines are, now the headlines, given an increase in traffic and given an equipage rate that would be, in our instance, I think it was 42% of the aircraft equipped, giving us 80% of the traffic. And on the assumption that the air navigation service providers are implementing, then we were looking at capacity benefits of 7 to 12%. Okay. Now there'll be other people in this room which would say, hey, if we could do this, it would be even greater. Okay. Now we can then extrapolate that and look at what the benefits would be in terms of environment, etc. But the main headline figure that we have in our work is that capacity increase is 7 to 12%, and then subsequently the benefits follow. If you look at our CBA, it's at the 4D Skyways. Google it. There's a CBA there, and you'll see the information. And I cannot remember the contents. Okay, but we have to do a CBA. That's part of the solution package that we deliver. Okay, in the context of an R&D project. Okay.
Thank you. Any additional question?
Hi, good evening, everyone. My name is Hermizan Jumari. I'm from Civil Aviation Authority of Singapore. My question is to Peter regarding the SESAR JU TBO research. A lot of the concept that has been presented with regards to network TBO and ATC TBO, specifically to the network TBO, hinge on the fact that network management or network manager exists. What does it mean for network TBO to be implemented or to be rolled out in other areas and regions where network management does not exist? So what are your views on this and how that can be applied? Thanks.
No, I can definitely phone a friend to get you to answer the question. I think that the key point is, and it is in the ICAO draft TBO concept version 0.11, and it's still draft, by the way, is that what is really important is that the network performance, the system performance is key. Okay, that's really the key point. So rather than a role of network manager, I think it's really the network performance is really key. And I think that Gerard is in a much better position to talk about that than I am. Okay.
Well, it's complicated because we work in an environment where we have the network manager. So it's difficult for us to imagine without the network manager for sure. I don't have the answer for you because unless you have, but for sure it helps a lot. And we saw also even for FFI's release 1 and the implementation of FFI's release 1, having the network manager is really a major asset in Europe. But without, for sure, for example, if I take the example of FFI's release 2 in the European context, I really don't see how we could implement that in the European context without the network manager. I think it would be very complicated. But it's a personal view, that part. But I can give you the floor if you want.
Yeah, thank you. Just to say the processes that are between the network manager and the NSPs is kind of what we have grouped into this concept of regional to try to separate. And actually what's in the network TBO project addresses both. So there are a number of projects that are addressing the interaction for the flight planning in pre-departure and post-departure between the network manager and the airspace user. That is between an ASP and the airspace user. It doesn't really matter if it's a network manager in Europe, let's say. The only thing that's good is that it covers a large area, but you know there are other ASPs that cover a large area, like I mean some of the ones we've spoken here, including the FAA. And then in all the processes that are for the aligning of the trajectory, between the network manager and the NSPs and between the NSPs, then that's more, if you like, Europe specific, except that we do need to increase the level of coordination between ASPs, and so somehow we see this as something to expand, I would say. I don't know if that clarified a bit.
Thank you. Next question over there, please.
Yeah, thank you. Arno from EUROCONTROL. I'm the manager of the Airspace and Procedures Design Department in my company. And I'm air traffic controller besides that as well. First, I would like to thank all the speakers because very good insights. And looking back a little bit in the past, I would like to raise the question what the experts think when this TBO concept might have a real future or a real time frame when we can talk about not a concept but a real thing that's happening. When I just look back about the CPDLC, for example, there were many fluffy words today mentioned about FFIs, SWIM, CPDLC, ADSB, ADSC, all those things that are some kind of pre-requirements for a running system of a called TBO. And not all, neither the NSPs nor the airliners are currently capable of even CPDLC or all the exchange and something like that. So all these stuff, for example, from the 80s are still not capable of doing this in the 2024 year. So my question is now to the experts, what do you think when this TBO might have a chance of being a running system?
So I'm going to jump in. I think it is already in some cases. We're talking about the idea. We're talking here, we're usually talking about big airports, large flows, complicated airspace. I think that there are many places where we're already seeing it at a smaller, more local level where it already exists. Anytime I can improve the coordination between a feeder airport and Chicago O'Hare, I've actually done a good job of doing TBO where I manage that flight by better coordination so it can get in there and not affect, I don't have the knockoff effects of the uncertainty. I think that's TBO. Now, if I'm flying from New York to JFK, or Chicago to JFK, that's a different type of TBO. So I think we can't always put ourselves at that marker where everything is done exactly the same. I do believe we have to share the information between all of our systems, but I think there's still room for voice in some cases. We're looking at or supplemented by other methods. We're looking at delivering of pre-departure clearances to small aircraft, not small aircraft, aircraft to small airports using mobile devices. Not push to load, but I can give you the clearance. I can make it more operational. I can improve the operation. And I don't have to depend on datacom. Now, if you're if you're flying at, 34,000 feet in the flow, then you really do need to be more equipped. But there's a lot of places where, the flight will only allow you really to get up to 22, 24, 28,000 feet. And we can accommodate you perfectly well without having to have a full datacom set. So I think we have to not stop TBO because we don't have everybody equipped the same. I think we have to be able to accommodate it. And I want to say one more thing because we didn't bring them up, but we did talk about them. I believe that the new entrants will be 100% TBO. I believe the aircraft that are takeoff fuel critical have to be fully time-based managed from the departure to the landing. And I think that that's where we're really going to see a lot of the advancements in intent and sharing of information, because these are not people who can sit around and wait to get a clearance to enter into Class B. Their diversion will be calling for the semi to pick them up off the side of the highway. So I really think we can look to the new entrants as being our stalking horse into full TBO. And the same principles hold for all of them. Now I overstayed my welcome and I will move on.
So in terms of the question, when would you be ready to implement TBO in Austrian airspace? Okay. I don't know what the roadmap is, but I think the combination of the regulation, which is kind of pulling, the buy-in from the controllers and the pilots, which is kind of pushing, but also the experiences that we have from Maastricht, where we have this opportunity, as the French would say, to do a tâche d'huile around Maastricht. I really think that that is the opportunity. So the roadmap, I don't know, but in terms of the confidence to make the decision to do it, I think the work is actually advancing quite well. Okay. And I believe that EUROCONTROL, you're in the Coupans Alliance, yes? So you're working with Thales, and really that's an important way forward. Yeah.
Amo?
Yeah, so but to answer your questions, my questions back would be, what's the scope of TBO that one wish for, one looking at? As we repeatedly said during all the presentation that we heard this afternoon, actually, TBO is include a lot of jigsaws in there, and some of the technologies capability already exists. And one that we demonstrate within our demonstration is that we use the existing technology on the aircraft. We develop some new capability in our ground system, but it's not all new. So it's already there. How we can make a better use of it, how we can integrate it, all those ingredients or those jigsaw together to do better coordination, have better information for our decision making and also situational awareness. And based on the experience that we have within the demonstrations, actually it's not like one size fit all, even though we have those jigsaw exist, is how I think the beauty that we learn from that demonstration is how we adjust those jigsaws, those components to fit our regional operational environment to deliver the operational benefit of TBO. If you could have a chance to take a look of the video that I provide the link, you will see that in 4 different segments that we run the live fire demonstration, it's all demonstrate different use cases with different operational scenario with all different TBO capabilities. And if you take a closer look at it, you have heard all about that before. It's already there. the components, how we integrate AMAN with ATFM functions, how we do better traffic synchronization is already there. So to answer your question, are we looking at the scope of TBO as the end goal, that we get it all, or we can make a better use of what we have right now, take a benefit out of it? That would be my response.
Thank you very much. Yes, please.
Yes, so hello. My question is about standards. I'm from a company who implemented a couple of years ago an AXM5 database, for instance, which was top-notch, the best exchange model. What we also heard just before, we all need to have the same context. That's what AXM is for. What we realized is that that the standardization is not high enough to make sure that if we have two vendors and both implement an AXM5 database, that they are compatible. And I see it a little bit here with TBO, also the danger. On one hand, we hear it has to be a global undertaking. We have all to implement it, but I think we also have all to implement exactly the same. We have many vendors that produce different systems, and if there is not a strict standard, then the systems will be different, and we will spend a lot of money and resources on ironing out the difference between the systems, because globally it has to be one system in the end. So my question is there a standardization body inside that will really standardize also the interfaces? And maybe is this part of the roadmap? That's my question, basically.
So yeah, it's a very good topic, very good question. We in Europe, I think, like I mentioned earlier, we are kind of experienced about having multi-vendors and many information models, and we've learned our lesson. So obviously, there's right now two main initiatives. So we have the FFIs, flight plan, and the SWIM standards. So that's already we think we're on the right path. And remember, it's not just the information models, it's also the processes, and we all call them the same way. And there is pretty good guidance developed within the ATM RPP. And I believe that's the way to go, and it's ready to support global implementation at like Crystal was saying, at the pace that each state needs it. Then on the airborne as well, there has been a long path, and we have good standards on the ATSB2. We have already revision A, and revision B as well is coming. And it's providing a lot more messages than we had before in the CPDLC, that's AV1, and the ADSC did not exist before. So there's already a very good initiative. There is, I think, an international consensus that has been done. And we are moving forward with, that's what we're using in our validations. And like I said, it's really addressing the aircraft control domain. Then we also believe that there is room for standardization in the area of connecting to the information service domain. But that for us, it's a new domain of research, so I wouldn't be able to comment. It may be a bit less critical in the sense that the different vendors may want to get their advantage, but there's also a huge amount to be gained by standardizing to some degree. And so that's, I think we will be able to answer more when we have more research.
Steve, you will be part of the networking event in response to that, because I really would like to close the session right now. Please, if you want to continue the discussion, please reach out to our speakers, to our presenters at the networking event. I would also like to strongly invite you to visit the stands and not only look into the presentations that you have seen, but also look into the practical examples that are going to be presented and shared with you. And finally, I would like again to thank all of the speakers of session 2 and session 3 and hand over to David.
Thank you very much, Sven. So that session brings us to the end of the first day. I hope you all agree it's been a very interesting afternoon. Of course, we have more to come tomorrow. Thank you all for being here today. We've had over 280 participants on site here, and I'm told we've had over 800 views online through the live streaming. We will, when we finish in here, outside, there is a networking reception, which I invite you to stay for, and all ask Steve your questions. Also, as has been mentioned, there are a number of exhibition stands outside. I haven't actually mentioned what they are yet. You've heard that there are a couple of stands showcasing the two SESAR projects, which you've heard about this afternoon. We also have stands from Airtel, ATN, from Boeing, Leonardo, and Thales. So I invite you to go and take a look at the exhibits. Also, for those of you who have signed up for the tours of the Network Manager Operations Center, there are 2 tours taking place after this session, one starting at 6 o'clock if you have an orange tour, one at 6:30, which is the blue tour. If you are on the orange tour, I invite you to follow my colleagues Marta and Florence, who are over there. Florence is in the beautiful red jacket, so you can't miss her. And with that, I think I've covered everything. Oh no, I've forgotten one thing. The presentations that have been presented during this symposium this afternoon will be made available on the EUROCONTROL website after the end of today. So if you go to the website where the TBO event is on the EUROCONTROL website, you'll be able to find these presentations. With that, thank you all, and thank you especially to the online participants who stayed with us. We will start again at 9 o'clock sharp tomorrow morning. Have a great evening. Thank you.